The water is warm, not the comfortable warmth of a summer shallows, but something older and thicker, a warmth that has no season because seasons here do not exist. You are suspended in it now, floating just beneath the surface of a sea that has no name, in an age that no human language has ever touched. The light above you filters down in long amber columns, shifting with the slow breath of waves you cannot hear from where you are. It is quiet. It is ancient. And it is, in ways that no creature alive can yet understand, almost over. This is the Permian Ocean. You are floating in it 252 million years before the world you know will exist. Beneath you, the seafloor drops away in gradual terraces of pale limestone, crusted with the delicate geometries of creatures who have never known a predator large enough to threaten them. Brachiopods cling to the rock with their hinged shells slightly open, filtering the water with the patient rhythm of things that expect to be here forever. A sea lily extends its feathered arms into the current, trembling softly, catching particles of food drifting down from the sunlit upper waters. A small fish, armored along its flanks in polished scales, drifts past you without concern. Everything here has been the same for a very long time. Somewhere far below the horizon, in directions you cannot name, the supercontinent of Pangaea sits like a vast brown wound across the face of the planet. Its interior is mostly desert. The rains come only to its edges, and even there they come cautiously. The world is drying. The world has been drying for millions of years. But here, in the warm, shallow seas that fringe the great land mass, life has not yet felt the trembling of what is coming. The water holds its temperature. The coral colonies spread another fraction of a millimeter. A nautiloid spirals slowly upward through the column of water, trailing its tentacles behind it like the fringe of a silk curtain. You are here now, floating. Still. The light is going golden as the hours pass, the way light at the end of an afternoon goes golden, though the sun here is slightly younger and slightly cooler than the sun you know, and the day is slightly longer because the earth spins a little slower in this time. The world above the water would be almost unrecognizable to you. The world below it, this world, feels strangely like rest. 12 hours from now, this sea will begin to die. But for now, it simply is. And you are in it. And that is enough. If you enjoy listening to sleepy prehistoric stories like this one, consider subscribing. New stories arrive every week, and the next one will be waiting for you whenever you need it. Let yourself settle now. Wherever you are lying, let the weight of your body sink a little further into the surface beneath you. You do not need to hold anything up tonight. You do not need to be anywhere. You are here, in the water, 252 million years ago, and the world around you is extraordinarily full of life. The Permian period has lasted 99 million years by the time you arrive in its final day. 99 million years. The number is almost impossible to hold, and so you do not need to try. What matters is what it means. This is one of the most successful chapters in the history of life on Earth. The oceans are rich with hundreds of thousands of species. The reefs are vast and complex, built over millions of years by coral animals so small that each individual is no larger than your thumbnail. The seafloor is layered with the shells of creatures that lived and died and settled into sediment with a patience that makes the word patience seem inadequate. On land, the scene is different but equally alive. Forests of fern and tree fern press against the edges of the continental coasts. Insects fill the air in numbers that stagger the imagination. Reptiles of many shapes move through the undergrowth, some of them surprisingly large, some of them surprisingly warm in their bodies, already edging towards something that will one day become the ancestors of mammals. The world is not gentle, exactly. Life is never fully gentle. But it is balanced. It has arrived at a complex equilibrium that has held, more or less, for a very long time. You are floating in the last full day of that equilibrium. Somewhere deep beneath the land, in a region that will one day be called Siberia, enormous quantities of magma have been moving upward through fissures in the crust for hundreds of thousands of years. Not rapidly. Not with any violence that anything on the surface can detect, but persistently, the way pressure moves, which is always forward. The lava has already begun to reach the surface in certain places, flowing across landscapes in dark rivers that cool into basalt. And with each eruption, with each exhalation of the deep earth, gases have been entering the atmosphere in quantities that are very slowly beginning to tilt the numbers. But the creatures of the Permian Ocean know nothing of any of this. They do not have the capacity to know it. They have only the current, the light, the slow chemistry of the water around them, and the reliable rhythm of finding food and avoiding being food. This is their entire world. And right now, in the amber hours of this ancient afternoon, their entire world is beautiful. You sink a little deeper. The light dims only slightly. Below you, a bed of sea lilies sways in a current so gentle it is almost not a current at all. A fish drifts past on your left, its scales catching the light for a moment before it curves away into the blue distance. You breathe slowly. The water holds you. Tonight, you are going to witness the end of a world, but it will be told to you gently, in the way that all endings deserve to be told, as something that happened a very long time ago, in a sea that no longer exists, to creatures who lived fully and completely in the time they were given. The reef begins somewhere beneath you, at a depth where the water turns from blue to a deeper, quieter shade of blue-green that has no proper name. It is not one reef in the way you might picture a reef. It is more like a city, built over thousands of generations, where the architects have all been too small to see without a lens, and where the building materials were made from the bodies of the builders themselves. Coral animals, each one a tiny polyp of translucent flesh encased in a cup of calcium carbonate it has secreted from the chemistry of the sea, have been constructing this structure for long enough that the oldest parts of it have become limestone, indistinguishable from the bedrock below. You drift over it now, and the scale of it settles on you slowly. The reef stretches in both directions along the coastline of a continent that will one day be unrecognizable, shaped by tectonic forces not yet finished with their work. To your east, the reef rises almost to the surface, its upper edges touched by the fractured light filtering down from above. To your west, it slopes away into the deeper water, its intricate surface growing darker and quieter. The corals there adapted to less light, their growth slower, their colours more muted. The whole structure breathes, not with lungs, but with the collective metabolism of every creature living on and within it, exhaling oxygen, absorbing carbon dioxide, cycling the elements of the sea through the machinery of their bodies in a chemistry so complex and interdependent that no single mind could ever fully chart it. A school of fish moves through the middle distance, perhaps 40 individuals, each one following the one in front with an accuracy that makes them look like a single organism. They are small, these fish, no longer than your hand. Their scales catch the light in a way that makes them shimmer as they turn, a collective flash of silver green that lasts for only a moment before they round the edge of a coral head and disappear into the shadowed interior of the reef. You watch the space where they were, and the water there is already filled again with the normal traffic of the sea. A nudibranch, orange and white, moves very slowly along a ridge of coral. A small crustacean, barely visible, picks through the sediment on the seafloor in quick, precise movements. The Permian Reef ecosystem is one of the most complex biological communities ever to exist on this planet. This is not rhetoric. The scientists who will one day study it, piecing it together from the compressed evidence left in the rock, will spend careers trying to describe its full complexity and will not quite succeed. The corals alone represent hundreds of different species, each one occupying a slightly different position in the structure, each one growing at a slightly different rate, feeding on slightly different particles, reproducing in slightly different ways. And the corals are only the foundation. Built on that foundation is every other thing you can see. There are sponges here, some of them as large as bathtubs, their bodies perforated with thousands of tiny channels through which they filter enormous volumes of water every day. There are echinoderms, the ancient group that will persist through every extinction to come and is still here in your own time in the form of sea urchins and starfish and sea cucumbers. The Permian versions of these animals are already recognizable in their basic architecture, though the specific species are different, and some of them are larger than anything in modern seas. A sea urchin the size of a dinner plate moves slowly across the face of a coral head, its hundreds of tube feet gripping the surface with an exactness that requires no conscious thought. You pass over a crevice in the reef and look down into it. The interior of the crevice is shadowed, but not dark. Light filters in from the opening above you, and from somewhere to your left, and in that filtered light you can see that the walls of the crevice are encrusted with life to every reachable surface. Bryozoans, colonial animals that build lacy structures of calcium carbonate, cover one entire wall in a pattern so intricate it looks like lacework set in stone. On the opposite wall, a different species of coral grows in dense brain-shaped formations, their surfaces covered in the faint lines of the individual polyps. At the bottom of the crevice, partly buried in the fine white sediment that has drifted down from the reef above, a trilobite rests. It is a large one. Its segmented body is perhaps 15 centimeters long, its compound eyes dark and still. It is not asleep, exactly, in the way you think of sleep, but it is resting, its metabolism slowed, waiting for the chemical signals in the water that will tell it when food is passing close enough to bother with. Trilobites have been on this planet for 300 million years by the time you float above this one. They first appeared in the Cambrian seas, and they survived the great extinctions of the Ordovician and the Devonian, adapting each time, finding new ways to persist. There are still many species of trilobite in the Permian seas. They are not at their peak, which was perhaps 100 million years ago, but they are here and they are successful, and this particular individual in this crevice has been living in and around this section of the reef for several years without serious incident. It does not know that it is one of the last. That knowledge belongs to the future, and the future is not here yet. Somewhere above you, the surface of the sea moves in long, low swells. The motion of those swells reaches you as a faint, rhythmic pressure, a pulse in the water. It is not unpleasant. It is the sea breathing, and you breathe with it, or rather you allow it to breathe you, rising and falling with the slow rhythm of ancient water. The reef absorbs the energy of the swells, converting it into sound, a low, continuous hiss and click that is the combined voice of every creature moving, every shell being shifted by a current, every small creature biting at a surface or retreating into a hole. It is a sound that has no human equivalent. It is not music exactly, but it has a quality that music sometimes approaches. It is alive, and it is constant, and it has been constant for a very long time. You let the current carry you a little further along the reef's edge. The afternoon is not aging yet. There is time. The water around you is unhurried, and so you are unhurried too. A sea turtle, large and deliberate, passes above you, silhouetted against the lighter surface. It is not a sea turtle in the modern sense. Not exactly, but something that occupies a similar role in this ecosystem. A large, air-breathing reptile that moves between the surface and the reef in its own slow schedule. It does not notice you, or, if it notices you, it does not consider you significant. It banks slightly on one flipper and angles toward the reef wall, and then it is past you, moving away into the distance until it is a dark shape and then nothing. The reef continues. It always continues. That is the impression it gives, that it is a thing without limits, without edges, that it simply goes on in all directions as far as the sea extends. And in the Permian the sea does extend very far. Pangaea is surrounded by a single great ocean called Panthalassa, which covers more than 2/3 of the planetary surface. The word means something like all sea, and on this day, in this late afternoon light, floating in the warm shallows at the edge of the great reef, the name feels accurate. The world is mostly water. The world has always been mostly water. The sea is the original home of life, and it shows. Even now, after hundreds of millions of years of evolution on land, the sea is more richly inhabited than any land surface on the planet. A current shifts slightly, a small change in temperature, a degree or perhaps less, moving through the water from the deeper regions to the west. Nothing reacts to it visibly. But the chemistry of the water has changed just slightly, and in some of the coral polyps, deep in the soft tissue of their bodies, certain proteins have registered the change. Not with alarm. The sea is always shifting, always changing in small ways. A degree is nothing. A degree is within the normal range of what the sea does from hour to hour. The polyps retract slightly into their calcium cups, the way they do sometimes in the afternoon when the light is too intense, and then slowly they extend again, their translucent tentacles reaching back into the water, and the business of the reef continues. You rest in the current. There is nowhere you need to be. The reef spreads out around you in all its ancient complexity, doing what it has been doing for millions of years. A brachiopod near your right hand opens its shell a fraction of a millimeter, and a thin stream of water moves through it, and something too small to see is caught in the filter of its lophophore and consumed. A small worm emerges from a tube in the sediment, waves its crown of feeding tentacles for a moment, and retreats. A cephalopod, related distantly to the nautilus above you, navigates the water column with its own quiet precision, its jet propulsion carrying it in a smooth arc from one part of the reef to another. The light is changing, not dramatically. The sun is still well above the horizon, wherever the horizon is in a direction you cannot easily determine from underwater. But the light has shifted from the direct white gold of midday to something slightly warmer, slightly more amber. The light that tells organisms in shallow water that the afternoon is progressing. In the deeper parts of the reef, certain animals are beginning to stir from their daytime resting places. A grouper-like fish emerges from a crevice and hangs in the water for a moment, its fins working slowly to maintain position before it moves out toward the open water in search of the smaller fish that will be more active in the evening hours. You watch it go. The reef absorbs its departure without comment. Somewhere below you, in the deep blue distance beyond the reef's edge, a shadow moves slowly through the water. Large, too large to resolve into specific shape at this distance. It is one of the larger predators of the Permian Sea, a shark-like creature whose lineage is ancient even by Permian standards, whose body plan has been so successful that it requires almost no modification from era to era. It is not moving with any urgency. It moves the way large, successful predators move when they are not actively hunting, with a kind of contained power that is itself a form of rest. It turns, very slowly, and the shadow that is its body catches the last angle of afternoon light for a moment, and you can see the pale underside, the long sweep of the tail, and then it turns again and descends, and the deep water swallows it. The reef is settling into the late afternoon rhythms that have governed it since before any creature alive today could remember. The day hunters are finishing their work. The night hunters are beginning to stir. In the middle of all this transition you float, neither predator nor prey, simply present, simply here. The water holds you in its ancient warmth. The reef continues its breathing. And somewhere, deep beneath the rock, beneath the ocean floor, beneath the continent that lies beyond the horizon, the earth is doing what the earth has always done, moving, slowly, without any concern for what lives on its surface. But that is later. That is always later. Right now, there is only this. The reef, the warm water, the amber light, the patient, ancient, intricate world going about its business as it always has, and as it believes it always will. If you are drifting now, let yourself go. Subscribe so the next story is waiting when you return. Sleep well. Consider, for a moment, the brachiopod near your left hand. It has not moved in the time you have been watching it, not in any way that registers as movement to your eyes. Its shell is closed or nearly closed, a thin slit of an opening at one end through which the water still moves, carrying with it the microscopic particles that are the brachiopod's entire food supply. The shell itself is unremarkable to look at, roughly oval, slightly ridged. A pale cream colour with faint brown striations. You could hold it in your palm and it would feel like nothing much, like a small, smooth stone that happened to have a particular shape. But the brachiopod is not a stone. It is an animal, and it is an animal with a history that stretches back more than 500 million years to the Cambrian seas where life was first learning what it could become. The brachiopod design, two shells hinged together encasing a soft body that feeds by filtering water, is so successful that it has persisted through every extinction event the planet has produced. It will persist through the one that is coming. The brachiopods of the Permian seas will be reduced severely by what happens in the next 12 hours and the months and years that follow, but they will not be eliminated. They will carry their ancient design forward into the next world, as they have carried it forward through every previous catastrophe. A small and unassuming testament to the survival power of a good solution. There are hundreds of species of brachiopod in the Permian seas. They come in many sizes, from tiny ones smaller than a grain of rice to large ones the size of your fist. They live at many depths, from the bright shallows where you are now to the cold, dark seafloor far below the reach of light. Different species have adapted to different conditions of temperature, pressure, oxygen concentration, and food availability. The one near your hand is a shallow water species, adapted to the warm, well-lit, food-rich environment of the reef margin. It has been living in this particular crack in the reef for 3 years, which is about as long as brachiopods of its kind usually live. You let your attention drift a little further, past the Brachiopod, past the next section of reef wall, to a region where the coral gives way to a cluster of sea lilies. Crinoids. They are called by the scientists who will name them in the distant future. From a distance, they look like flowers. Their stems are long and flexible, anchored to the reef surface by a root-like structure called a holdfast, and from the top of each stem a crown of feathered arms extends into the current. The arms move with a languorous, hypnotic rhythm, opening and closing in the flow of water, catching particles of food with the tiny structures that line each arm. In the Permian, crinoids are extraordinarily abundant. They grow in dense meadows on many parts of the seafloor, their stems sometimes so closely packed that the area below them is in permanent shadow. Some species grow very tall, their stems reaching a metre or more above the sediment. Others are short and compact, growing in the more exposed areas where stronger currents would snap the longer stems. The ones you are watching now are medium-sized, their stems perhaps 40 centimetres, their arms spread in a graceful fan that faces the current and does not fight it. Something small and quick darts through the meadow of crinoids, too fast to follow clearly. A fish, perhaps, or a swimming crustacean. The crinoids nearest to its path contract slightly, their arms closing like slow flowers responding to the wrong kind of touch, and then, as the disturbance passes, they open again, one by one, resuming their patient feeding. The meadow is still again. The current continues. The arms of the crinoids trace their slow arcs through the water, and whatever was caught in them is transferred imperceptibly to the small mouths at the centre of each crown. What does it mean, you might wonder, to feed this way, to be rooted to one place and to wait for the food to come to you? The crinoid has no anxiety about this. It has no capacity for anxiety. It has a nervous system that is simple enough that the word nervous system almost seems too grand for it. A network of cells that carry chemical signals from one part of the body to another, allowing the arms to respond to touch, to retract when damaged, to orient toward the current. That is about the extent of the crinoid's experience of its own existence. It does not know that it is in danger. It does not know anything, in the sense that knowing implies. But it is alive, and it is thriving, and in the afternoon light of this last full day of the Permian world, it is doing exactly what it was built to do. You move away from the crinoid meadow and follow the contour of the reef as it curves gradually outward, toward the open water. Here the reef wall drops away more steeply, and the creatures that live on this face of it are adapted to slightly different conditions. There is less light here, and the currents run stronger, bringing food from the open ocean. The corals on this face tend to grow in long, branching forms, rather than the massive mound shapes of the shallower reef, their branches oriented to maximize the surface area exposed to the current. Between the branches, a different set of animals shelters. Small fish in larger numbers, more crustaceans, worms whose tubes are anchored to the coral surface with a tenacity that would require deliberate force to overcome. A large nautiloid appears from the blue water to your left. You have seen smaller ones, but this one is impressive. Its coiled shell is perhaps 30 centimeters across, its surface a pale cream with faint brown stripes. It moves through the water in a series of smooth, controlled pulses, its jet propulsion carrying it forward in a trajectory that curves slightly, the way things curve when they are navigating between obstacles. Its tentacles hang below the opening of the shell in a loose bundle, ready. It is not hunting aggressively right now. It is moving with a kind of calm purpose that suggests it is going somewhere. It knows, following a chemical trail or a depth gradient, that means something in its navigational vocabulary. The nautiloid passes within a metre of you and pays you no attention. Its eyes, which are surprisingly complex for an animal of its kind, move independently on either side of its head, registering movement and light without, so far as you can tell, registering you as anything requiring a response. It continues its curving trajectory and disappears around the corner of a coral head, leaving a slight turbulence in the water that dissipates in a few seconds. The reef closes over the fact of its passing. You have been watching these animals for what feels like a long time, though time moves differently when you are floating in warm water in the middle of the afternoon, with nowhere specific to go. The light has not changed much. The afternoon is still the afternoon. But you have a sense, a quiet background sense of the day advancing. The reef community is moving through its daily cycle, And the cycle is a long one, measured not in hours, but in the habits of thousands of species acting out their individual lives in a space they all share. There is a shark below you, not a large one. A small species, perhaps a metre long, with a body plan that is already essentially modern, because sharks have been getting this right for a very long time and have found no compelling reason to change it. It moves along the base of the reef wall with a sinuous efficiency, its pectoral fins making small adjustments to its altitude above the sediment. It is hunting, but without haste. It is following the chemical traces of small organisms in the sediment, the faint signals of living things buried just below the surface of the sand. Occasionally it dips its snout to the sediment and investigates, and occasionally it finds something worth eating, a small worm or crustacean, and consumes it with a quick snap that raises a small cloud of sand and then settles again. The shark's existence is simple in the best possible sense. It is not simple because it is primitive, because a shark is not primitive. It is simple because it has arrived at an extremely efficient way of being in the world and has had no reason to depart from it. It eats. It moves. It reproduces. It navigates the chemical and electrical landscape of the sea, with sensory systems so acute they border on the extraordinary. It has been doing this, in essentially this form, since before the first trees grew on the land above, and it will be doing it, in essentially this form, long after everything you are watching today has been buried in limestone and forgotten by every creature then alive. You let the shark go about its business and return your attention to the middle water. There are so many things here. There are always so many things here. Every cubic metre of the reef environment contains dozens of organisms, from the visible ones you can follow with your eyes to the invisible ones that fill every layer of the water column, bacteria and archaea, and tiny single-celled creatures whose names and natures will not be known for another 252 million years. They are all here now, all of them going through their own quiet existences in the amber afternoon of the Permian Sea, and none of them knows what you know, and none of them could be troubled by it if they did. This is what the Permian Sea is. A complexity so deep that no single mind has ever fully comprehended it, sustained by a chemistry so balanced that even small perturbations take a long time to register as change. The sea absorbs a great deal. It has always absorbed a great deal. It is built for absorption and recovery. The geologic record is full of evidence of its capacity to bounce back from disruption, to find new equilibrium, to return to the business of life with a resilience that makes resilience seem too small a word. But there are limits. There are always limits, and tonight the limits will become visible. For now, though, the reef goes on. A fish you have not noticed before emerges from behind a coral head and hangs in the water in front of you, its fins beating rapidly to maintain its position in the slight current. It is a beautiful fish. Its scales are dark blue along its back and fade to silver on its flanks, and its fins have an elongated elegance that suggests a creature shaped by millions of years of specific pressure. It regards you or the space you occupy for a moment, then it turns and goes, and you remain, and the afternoon continues, slow and warm and full of life, deeper than you are now. The sea changes its character. The light that filters down from the surface grows thinner and bluer, and eventually gives out altogether at a depth that varies with the clarity of the water. In the Permian seas, the water is generally clear, because the reefs and the planktonic organisms that live in the upper water column are so abundant and so efficient that they remove most particles from the water very quickly. Light can reach surprising depths here, but it cannot reach all depths. And below the reach of light, the sea becomes something different. You are not going to descend into the deep water tonight. The deep water is cold and very dark, and the creatures that live there are strange in ways that even the patient narration of a sleep story cannot easily render comfortable. But it helps to know that the deep water is there, and to understand something of what it does for the ocean above it. The deep sea is, among other things, a storage system. Cold water, dense and slow-moving, sinks from the polar regions and moves along the bottom of the ocean in currents that take centuries to complete their circuits. As this cold water moves, it carries with it dissolved oxygen from the surface, and it carries with it the sinking particles of organic matter from the productive upper layers, and it distributes these things across the floor of the ocean in a slow, steady rain of nutrition. In the healthy Permian Ocean, this deep circulation is active and well-functioning. Cold bottom water moves around the globe, Nutrients are distributed. The oxygen content of the deep sea, while lower than the surface, is sufficient to support life. The deep sea floor has its own community of organisms, adapted to cold and dark and pressure and a slower pace of arrival of food. Worms. Strange echinoderms. Bacteria in vast quantities. The occasional large scavenger, drawn down from shallower water by the smell of a carcass. Settling from above. It is a different world from the reef above you, but it is a world, and it is alive. This deep circulation is important for reasons that go beyond the distribution of oxygen and nutrients. The ocean is the planet's primary regulator of temperature, and the circulation of its water from surface to deep and back is the mechanism by which it performs that regulation. Cold water absorbs heat from the atmosphere and carries it down. Warm water at the surface releases heat back to the atmosphere. The system moves enormous quantities of energy around the planet, moderating the extremes that would otherwise make the poles far colder and the tropics far hotter. Without this circulation, the distribution of life on the planet would be very different. You do not feel the deep water from where you are. You feel only the warm, light-touch surface layer, the gentle pressure of the water above you, the slow pulse of the surface swells translated into a faint rhythm in the column of water. But knowing the deep water is there, knowing it is circulating, knowing it is doing its slow work of regulation and distribution, adds something to your sense of the ocean's completeness. The sea is not just what you can see. It is a system of enormous depth and complexity, and you are floating on its surface layer the way a leaf floats on the surface of a pond, touching the water, part of it, but knowing almost nothing of what lies below. What lies below tonight includes something that has been building for a very long time. Not in the deep water exactly, but below it, in the sediment that has accumulated on the seafloor over millions of years. In certain regions of the Permian Ocean floor, particularly in the areas where the circulation is slower and the oxygen content of the bottom water is lower, there are thick deposits of organic matter that did not fully decompose before they were buried. This organic matter is compressed into sediment, and in the sediment it is processed by bacteria that work without oxygen, producing methane and hydrogen sulfide as byproducts of their metabolism. These gases accumulate in the sediment, held there by pressure and by the weight of the water and the rock above them. The hydrogen sulfide is particularly significant. It is a gas with a distinctive smell, the smell of rotten eggs, a smell that any organism with a nose learns very quickly to avoid because it is toxic. The bacteria that produce it are ancient, far older than the complex life of the reef above. They belong to a lineage that predates the age of oxygen, that evolved when the sea itself was anoxic and they were among the only living things in it. They are still here, in the dark sediment, going about their anaerobic metabolism, and in the dark sediment they are harmless enough. The hydrogen sulfide they produce is absorbed by the sediment, or reacts with the minerals there, or, in very small quantities, diffuses up into the deep water where it is diluted to concentrations too low to matter. But if the deep water were to lose its oxygen, the chemistry would change. Without oxygen, the bacteria that normally consume hydrogen sulfide as fast as it is produced would not function. The gas would accumulate. In the deep water, it would build up to concentrations that would kill the animals living there. And if it built up enough, if the anoxic layer rose high enough in the water column, it would eventually reach the productive upper layers where the reef communities live, and there it would find organisms with no tolerance for it at all, organisms whose entire metabolic architecture assumes that the water around them is oxygenated and free of poison. This is the mechanism of one of the largest mass extinctions in Earth's history. Not an asteroid, not a volcanic winter that blocks the sun, but a change in ocean chemistry, driven by warming, driven by the loss of deep circulation, driven by the accumulation of carbon dioxide from the lava fields that are even now spreading across what will one day be Siberia. The mechanism is slow. It has been building for hundreds of thousands of years, and it will continue to build for hundreds of thousands of years after tonight. But tonight, in certain parts of the deep ocean, the process has already crossed a threshold. The deep water is already losing its oxygen. The hydrogen sulfide is already accumulating in places where it has never accumulated before. You do not know this from the water around you. The water around you is clear and warm and oxygenated and full of life. The reef below you continues to grow. The fish continue to move in their patterns. The crinoids continue to feed. The brachiopods continue to filter. None of this registers anything unusual. The chemistry of the surface water is still within the normal range for the Permian Sea, still capable of supporting the extraordinary diversity of life that has built up over millions of years. But the margins are changing, very slowly, by fractions that no individual organism is capable of detecting. What does it feel like to be on the edge of something enormous and not know it? What does it feel like to go about your ordinary life in the ordinary way, doing the things you have always done, responding to the signals you have always responded to, and to have no capacity to sense that the system you depend on is shifting beneath you? The reef animals have no capacity for existential dread. They have no concept of endings. They have only the present moment, the current signal, the immediate fact of alive or not alive. And in the present moment they are alive, and the sea is warm, and the afternoon is continuing. A large fish passes overhead, its shadow briefly dimming the light around you. It is moving in the direction of the open ocean, unhurried, following a route it takes every afternoon at approximately this time. Its brain, which is more complex than any invertebrate brain in the reef below but simpler than the brain of any land vertebrate alive on the continent above, is processing the navigation signals that tell it where it is and where it is going. It has no sense of danger. It has no reason to have a sense of danger. Its entire life history says that the ocean is large and productive, and that following the normal patterns will produce food and safety and eventually reproduction. You watch it go. The water closes behind it. The reef continues. The afternoon continues. Somewhere below the seafloor, in the compressed sediment of millions of years, the bacteria continue their ancient work, producing their ancient gases in quantities that are, for now, still within the range that the system can absorb. But the range is narrowing. Degree by degree, as the planet warms and the deep circulation slows, the margin between equilibrium and catastrophe is becoming thinner. You breathe. The water breathes. The reef breathes. And the afternoon deepens, the light shifting toward the gold that comes before the gold that comes before the dark, and the world of the Permian Sea goes about its last full business with the unhurried confidence of something that believes itself permanent. Is there beauty in not knowing? The reef does not know what is coming, and perhaps because it does not know, it continues to be exactly what it is, fully and without reservation, to the very end. There is something in that worth sitting with. The present moment, fully inhabited, is its own completeness. The current shifts slightly again. The crinoids lean a fraction of a degree. A fish adjusts its position. The sea continues. The light is changing now in a way that the reef can feel. Not the light from the distant volcanic province, which is invisible from here, hidden below the horizon by 1,000 kilometers of ocean and the slight curvature of the earth. The light changing now is the sun, following its arc across the Permian sky, moving toward the horizon in the west. The sea surface above you catches the lower angle of light differently, breaking it into longer, warmer shafts that cut through the water at a shallower angle and reach less deep than the midday light did. The uppermost surfaces of the reef glow with this warm light. The deeper sections are settling into a bluish shadow that will deepen through the evening. The reef community has been responding to this change all afternoon, in the slow, chemical way that organisms without clocks respond to the passage of time. The day-hunting fish have been gradually reducing their activity. The animals that shelter in crevices during daylight hours are beginning the slow process of waking, extending tentacles or antennae to sample the water for the chemical signals that tell them whether it is safe to emerge. A lionfish, its body extravagant with elongated fins striped in red and white and brown, has been motionless in a crevice for most of the day, and is now becoming slowly, marginally more alive, moving its fins in small testing waves, sampling the ambient water. You drift past the crevice and watch the lionfish become itself. It is one of the most beautiful animals in the reef, and also one of the most dangerous to approach, though danger is a word that belongs to your frame of reference rather than to the reef's. The venomous spines along its dorsal fin are not weapons in the offensive sense. They are tools of last resort, employed only when the fish is seized by something that did not notice or did not care about the warning coloration. The bright stripes say, as clearly as colour can say anything, I am not a good choice. Most predators in the Permian Sea have learned to read this message. The lionfish emerges from its crevice in a slow, unhurried movement, its pectoral fins spread wide, its body barely disturbing the water as it moves. It hangs in the open water for a moment, assessing. Its eyes move independently, each one scanning a different field. There is nothing to alarm it. The reef around it is doing its evening business, and the lionfish is a known quantity here, a fixture, something the other animals have accommodated into their understanding of the space. It drifts toward the reef wall and begins to move along it at a height of about a meter above the seafloor, looking for the small fish and crustaceans that will come out in the hours ahead. Twilight in the reef is not the same as twilight on land. The water filters and diffuses and slows the change in light, so that the transition from day to evening is a gradual gradient rather than a threshold. There is no moment when you would say the day has ended. There is only a slow, continuous deepening of the blue, a slow, continuous shift in the character of the activity around you. The day community and the night community overlap for hours in the evening, their respective animals passing each other in the same water, each following its own chemical clock, with the unconcerned focus of organisms that do not need to know about the others to do what they do. A small group of crustaceans emerges from the sediment near the base of the reef wall. They are amphipods, small shrimp-like animals that spend the day buried in the sand and the night picking through the seafloor for organic particles. There are perhaps a dozen of them in this group, and they move with a frenetic energy that is very different from the slow pace of the animals you have been watching. They cover ground quickly, their multiple legs working in rapid coordination, their antennae constantly probing the water and the sediment for chemical information. They are prey for many things, and they know this in the only way they can know it, as a background urgency that keeps their movements quick and keeps them close to potential shelter. You watch them for a while. Their energy is contagious in a small way, a reminder that not everything in the reef moves at the pace of the tide. Life here is not uniformly slow. It operates at many speeds simultaneously, from the near stillness of the brachiopod to the frenetic scuttle of the amphipod, and all of these speeds are equally equally valid responses to the conditions of the reef. The brachiopod's patience and the amphipod's urgency are both solutions to the same problem of existence in this particular place at this particular time. The temperature of the water around you is very slightly cooler than it was an hour ago, not noticeably cooler in any way that would make you shiver, even if you were capable of shivering. But the coral polyps are aware of it. In the upper layers of the reef, where the temperature differential between day and night is larger, the polyps have been extending slightly more of their tentacular surfaces as the temperature drops. Taking advantage of the slightly slower metabolism this induces to conserve energy. In the Permian, the daily temperature cycle of the reef water is smaller than in most modern reefs, because Pangaea's interior generates warmer air that moderates the temperature swings. But there is still a cycle. There is always a cycle. You think about cycles. The reef itself is a kind of cycle, building over thousands of years and occasionally disrupted and rebuilt, accumulating and eroding, the stone that was once living matter becoming the foundation for more living matter. The day and night cycle you're experiencing is nested inside the seasonal cycle, which is nested inside the longer cycles of climate and tectonic activity that operate on timescales of millions of years. All of these cycles are running simultaneously, intersecting in complex ways, creating the conditions for life at every scale from the bacterium to the biosphere. There is a fish near you now that was not there before. It appeared from somewhere while you were watching the amphipods, and now it is hovering perhaps 2 meters away, facing slightly away from you. It is a medium-sized fish, perhaps 40 centimeters, with a body that is deeper than it is wide, giving it a disc-like profile that is well suited to maneuvering in the complex three-dimensional architecture of the reef. Its colors are muted, browns and greys that blend with the coral, and it moves with the careful, deliberate quality of a predator who relies on patience rather than speed. It is watching a small fish, barely 5 centimeters, that is feeding among the branches of a coral head nearby. The small fish is unaware of the predator, or appears to be unaware of it. It is picking at the surface of the coral, taking small bites of algae and the tiny organisms that live in and on the coral surface, moving from one spot to another in the distracted, variable way of animals that are eating, and not thinking about much else. The larger fish holds its position, waits, does not move in any way that would alert the smaller one. You have seen this before, in other seas, in other times. The patient ambush of a predator who has learned that stillness is often more effective than speed. The outcome is not in doubt, not if you have watched enough reefs. But the moment before the outcome is a moment of pure presence, both animals existing completely in the now, one absorbed in feeding, one absorbed in waiting, neither one doing anything except what it is built to do. The larger fish moves. Very fast for an instant. There is a disturbance in the water, a quick swirl, and then the larger fish is still again, and the small fish is not there anymore. The coral surface where it was feeding is undisturbed. The other small fish that were feeding nearby have scattered momentarily into the coral and are already beginning to drift back out. The larger fish chews once, twice, and is finished. It resumes its position, looking away from you, its body relaxing back into the careful stillness of the reef predator, who knows that the next meal may also be a matter of patience. This is how it goes. This is how it has always gone in the reef. The big eat the small, the fast eat the slow. The camouflage survive and the visible do not. The system is not cruel, in the sense that cruelty requires intent. It is simply efficient in the ruthless, impersonal way of natural systems. Every death in the reef is also a transfer of energy, the chemistry of one organism becoming the chemistry of another, the proteins of the small fish now being processed in the digestive system of the larger one, destined to become the larger fish's body, its movements, its eventual reproduction. Nothing is wasted. The reef wastes nothing. The evening deepens around you, the light has shifted further toward blue, and the water above you is darker than it was. The surface swells visible not as light but as movement against a dimmer sky. You cannot see the stars, though they are there, in a sky that has never held a human eye. The Milky Way hangs over the Permian Ocean as it hangs over everything, ancient and indifferent, its light falling on a world that does not know it is being watched. You float. The current is very gentle now, barely perceptible. The reef is settling into its night mode, the slow handover from day species to night species proceeding without drama, without ceremony, as it has every evening for millions of years. You are part of this, or at least you are in it, and being in it, you feel something of its rhythm, its patience, its long, slow confidence. The world has been doing this for a very long time. It will go on doing it, in one form or another, for a very long time to come. Even after tonight, imagine for a moment the land. You are in the water, and the water is where you will remain, but it helps to know what exists above the surface, beyond the horizon, on the vast and strangely shaped continent that surrounds this sea on so many sides. The land is Pangaea, and Pangaea is not like any continent that exists in your time. It is all the continents together, compressed into one enormous mass, stretching from pole to pole and from one side of the planet to the other, its interior a vast desert of rock and dust, its edges an irregular coastline where the sea and the land negotiate their boundaries. The coast nearest to you is perhaps 20 kilometers away. You cannot see it, of course, from the water, but you could imagine it, low cliffs of pale limestone, cut by the sea into ragged shapes. A narrow band of beach where the waves spend themselves in long, shallow runs of foam. Above the beach, the land rises in rocky terraces toward the interior, and on those terraces there is vegetation, though not the kind you know. There are no grasses here, no flowering plants, no trees in the sense of the oak or the maple or the pine. The vegetation of the Permian coastline is a landscape of ferns and seed ferns and tree ferns, of plants belonging to groups called lycopsids and sphenopsids and chordatilians, names that mean nothing to you now, but that refer to specific lineages of plant that have been doing well for millions of years and are doing well still, up to a point. The forests are not dense everywhere. The Permian climate has been drying for millions of years, and the interior of Pangaea receives very little rain. But the coastal margins, where moisture from the sea moderates the aridity, support forests of a kind. Tree ferns with trunks as thick as a person's waist, reaching 10 or 15 meters, their fronds spreading in circles at the top like enormous green umbrellas. Chordatilian trees with long, strap-like leaves and straight trunks that would not look entirely wrong in a modern temperate forest, except for their scale and the strangeness of their reproductive structures. Between these larger plants, a dense understory of smaller ferns and mosses and plants whose names belong to groups that do not survive what is coming. In those forests, there are animals. Land animals, evolved over hundreds of millions of years from the first fish that dragged themselves out of the Devonian seas diversified through the Carboniferous swamps, survived the smaller extinctions of the Mississippian and the Pennsylvanian, and arrived here in the Permian with a remarkable variety of forms. There are insects, of course. Insects were on the land before almost anything else, and they are still here in extraordinary diversity, filling every available role from pollinator to decomposer to predator of other insects. There are arachnids. There are myriapods, the centipedes and millipedes, still doing the work they have been doing since the Silurian, processing the organic litter of the forest floor. But the most interesting animals of the Permian land are the synapsids. This is the group that will, eventually, give rise to you. Not immediately. The path from the Permian synapsid to the modern human is a long and complicated one, full of dead ends and near misses and improbable survivals. But the basic lineage is there, in the late Permian forests, and if you could stand in those forests and look at the animals moving through them, you would find, in some of them, the very distant outlines of something familiar. The dominant large synapsids of the late Permian are a group called dicynodonts. They are, in appearance, somewhere between a large reptile and something you might, in dim light, mistake for a stocky, heavily built mammal. They are typically between the size of a rabbit and the size of a cow, depending on the species, and they are herbivores, feeding on the tough vegetation of the Permian forests, with a specialized beak that was highly effective for cutting through the stems of plants. They have no teeth, most of them, only a pair of large tusks in the upper jaw that may have been used for display or for digging up roots. There are many species of dicynodont in the late Permian, occupying many different body sizes and ecological roles. Some are very small and burrow in the forest floor. Some are very large and browse the higher branches of the tree ferns. Most are somewhere in between, moving through the landscape in herds or small groups, cropping the vegetation with their beaks, processing enormous quantities of plant material to extract enough nutrition. They are not graceful animals, in the visual sense. They are solid and methodical and somewhat ungainly, but they are extraordinarily successful. They are one of the most numerous large animals on the Permian land surface, found on every part of Pangaea where conditions allow large terrestrial herbivores. The predators that hunt the dicynodonts are also synapsids mostly. The most impressive is a group called gorgonopsids, large and with a body plan that is genuinely intimidating. The largest gorgonopsids reach 3 meters in length, with skulls that are perhaps 40 centimeters long and filled with large, serrated teeth, including a pair of canine teeth that are enormous by any standard. They move with a gait that is more upright than most reptiles of the time, their legs beneath their bodies rather than sprawling to the sides, giving them a speed and maneuverability that makes them effective hunters. On the coast, where the land meets the sea, there are animals that occupy the interface. Amphibians, large ones, some of them 3 or 4 meters long, lying in the shallow margins of rivers and estuaries with a patience that matches the brachiopods you left behind in the sea. These animals breathe air but return to water to reproduce, as amphibians still do in your time, and they spend much of their time in a state of low-energy waiting, lying in the mud or the shallows, conserving resources, ready to lunge when something edible comes close enough. The evening is coming to the land as well as to the sea. On the terraces above the beach, the tree ferns have already fallen into shadow, their fronds dark against a sky that you can imagine turning from blue to orange to the deeper colours of evening. There are insects out, filling the air above the coastal vegetation in the way insects fill the air above any productive habitat. The dicynodonts in the lowland forests near the coast are settling into their night resting places, groups of them gathering in cleared areas where the sight lines are long and the approach of a gorgonopsid would be visible from a distance. The gorgonopsids, for their part, are becoming more active as the light fails. They are better hunters in low light. Their eyes adapted for the dim conditions of the forest floor after sunset. There is one, somewhere above the beach on a limestone terrace, who has been watching a small herd of dicynodonts for the past hour. It has not moved. It is lying flat against the rock, its body temperature rising slightly as its metabolism anticipates the hunt. It is waiting for the dicynodonts to settle, to relax, to stop scanning the surrounding area with the nervous vigilance of animals who know they are prey. From the sea, none of this is visible. The coast is too far. The actions on the terraces are invisible behind the limestone cliffs in the distance and the darkening sky, but the sea receives evidence of the land's existence in other ways. The rivers that drain into it bring nutrients from the soil. The winds that blow off the land bring dust and pollen and the occasional spore of some plant launching its reproductive material into the air. The tidal rhythms that govern the behavior of the animals in the intertidal zone are a product of the interaction between the sea and the gravity of the moon, which does not care about the distinction between land and ocean. The land and the sea are not separate worlds. They are two aspects of a single planetary system, exchanging matter and energy across the boundary of the coast, each one affecting the chemistry and the biology of the other in ways that have been developing since the first organism made the transition from water to land 500 million years ago. The sea feeds the land with moisture. The land feeds the sea with nutrients. The creatures of the coast move between them, some returning to water to breed, some making the crossing in the other direction, some spending their lives exactly on the line between the two. You are in the sea. The land is there, invisible, in the direction of the lessening light. And the evening that is settling over the sea is settling over the land as well, bringing the same cooling of the air, the same shift from one set of behaviours to another, the same ancient and continuous business of life carrying itself forward through the hours. What is happening underground, beneath both the sea and the land, is invisible to all of it. The magma moves, the gases accumulate. The chemistry of the planet pursues its own agenda, indifferent to the complexity of life on the surface, indifferent to the Brachiopods and the nautiloids and the dicynodonts and the gorgonopsids and everything else that has spent the last 100 million years learning to be exactly what it is. But the day is not over yet. There is still the night to come, and the night, in the Permian Sea, is its own country. The dark comes slowly to the sea. It does not arrive the way dark arrives on land, as a sudden shift in the quality of the light, a line that moves across the ground from east to west with the setting of the sun. In the water, darkness is a process. The surface above you goes from pale gold to deep orange to a rich, fading amber, and then the amber drains away, and what is left is a deep, luminous blue that is not quite dark, not quite light, but something between the two, a colour that has no exact equivalent on land. You are deeper now than you were. Not much. Perhaps 10 metres below the surface, where the last of the direct sunlight does not quite reach, where the light is diffuse and even and comes from all directions at once rather than from above. In this light, the reef takes on a quality that is different from its daytime appearance. The colours are muted. The bright pigments of the corals and the fish, so visible in the full light of the afternoon, are now flattened into shades of blue and grey, and a blue that is so dark it is almost black. But the shapes are still visible. The complex architecture of the reef is still there. The branching corals and the massive heads and the ridges and crevices, all of it rendered in these deep blue tones like a sketch of itself, in a medium that does not include warmth. This is the hour when the reef is most itself. Or rather, when it reveals a self that the daytime hides. The animals that are strictly nocturnal, the ones who have spent the day invisible in crevices or buried in sediment, or tucked into the interior spaces of the reef structure, are now emerging, and the reef is filling with a different set of actors playing their own version of the same drama that plays during the day. The cast changes completely. Twice. Every 24 hours. This has been happening since before the reef was a reef, since before the first coral polyp secreted its first calcium cup. Day and night, life and life, the same stage, different players. A moray eel emerges from its den in the base of a coral head. It is a large one, perhaps 1.5 meters, its body a deep brown mottled with a pattern that matches the coral and the rock, so well that it seems to materialize from the reef itself rather than emerge from a specific hole. It moves with the sinuous, boneless-looking quality of all eels, its head lifting to taste the water, its small eyes scanning the area around the den opening. It finds nothing of immediate interest and begins to move along the base of the reef wall, its body making the long, curving waves that propel it forward with surprising speed for something that looks so languid. The moray does not use vision as its primary sense at night. It uses smell and taste, which are the same thing for a fish, chemical receptors in the water that tell it what is nearby and what that nearby thing is doing. Its sense of smell is acute enough to follow a trail of blood molecules diluted to parts per billion in the surrounding water. A wounded fish anywhere in the vicinity of the moray is a wounded fish the moray will find. This is not cruelty, it is simply function. The moray does not think about cruelty, it thinks about nothing. It follows the chemical gradients of the sea with the precision of an instrument designed for exactly this purpose. Other animals are emerging around you. Crustaceans that spent the day in their burrows are now active in the open water, their antennae sweeping the current for chemical information, their legs carrying them in quick, precise movements across the seafloor and up the reef walls. Worms that were invisible during the day are now extended from their tubes, their crowns of feeding tentacles reaching into the night water. Somewhere in the distance, a grouper that was hiding in a crevice during daylight has emerged and is moving along the reef edge in the slow, deliberate pattern of a large predator on a night patrol. The planktonic organisms, which spend the day in the deeper water where they are less exposed to predators, have begun their nightly migration toward the surface. This migration happens in every ocean on Earth, every single night, and it happens in the Permian Ocean as well. The tiny animals of the plankton moving upward through the water column as the light fails, rising toward the surface where the food is richest, and then descending again before the dawn. It is one of the largest animal migrations on the planet, measured in terms of total biomass, and it is invisible to almost everything, because it happens in the dark and involves organisms too small to see without magnification. But the plankton feeders know it is happening. The fish and the nautiloids and the larger invertebrates that feed on planktonic organisms follow the migration upward, and the predators that feed on these plankton feeders follow them in turn. The entire water column is in motion tonight, the night shift of the ocean's workforce spreading through the water to do the work that needs to be done in the dark. And all of this has been happening every night, since before the reef was built, since before the corals existed, since the very first complex animals swam in the Cambrian seas and began the division of the day into light hours and dark hours, each with its own set of participants. You have drifted slightly away from the reef during the evening, carried by a current so gentle you did not notice it. Now you are in the open water, perhaps 30 meters from the nearest reef edge, floating in the dark column of the sea. The reef is a dark shape to your right, its outline visible against the slightly lighter open water. Above you, the surface is a moving ceiling of black and silver, the waves visible as dark shapes against a sky that, if you could see it from above the water, would be blazing with stars. Out here, away from the reef, the water has a different quality. It is quieter, in the sense that there are fewer large organisms and the sounds they make are fewer and more distant, but the chemistry of the water is alive with information. The planktonic organisms around you are communicating through chemical signals. The currents carry traces of every living thing they have passed through. There is a faint luminescence in the water, produced by planktonic organisms that generate their own light as a byproduct of certain metabolic processes, or as a response to disturbance. When you move your hand through the water, the motion triggers tiny flashes in the organisms you disturb, a scattering of blue-green light that lasts for a fraction of a second and then fades. Bioluminescence. It is one of the oldest forms of light production in the living world, evolved independently in many different lineages, serving many different purposes. Some organisms use it to attract prey, some use it to confuse predators, some use it for communication with others of their kind. The planktonic organisms around you use it in response to mechanical disturbance, perhaps as a way to startle predators, perhaps for reasons that have not yet been fully understood by the future scientists who will study their distant relatives. Whatever the reason, the effect is beautiful in a way that beauty does not usually require a reason. You float in the bioluminescent sea and let the small lights move around you. Each one is a living creature, each one a flash of chemistry, each one a brief presence in the dark water that existed before your arrival and will continue after you are gone. The total number of these creatures in the Permian Ocean is beyond any number you could meaningfully hold in your mind. They fill every part of the ocean that is not already filled with something larger. They are the base of the food web, the foundation on which everything else rests, the reason the fish are here and the reef exists, and the nautiloids spiral through the dark water in their patient arcs. The night is deepening. The bioluminescence is a constant, subtle presence around you, a soft illumination that does not reveal much but suggests an endless depth of life in all directions. Somewhere in the deep water below you, things are moving that you have not seen and would not easily understand. Large things and small things, all going about the business of the night ocean with the same unhurried efficiency that characterizes everything here. The sea does not rush. The sea does not need to rush. It has time. in quantities that make your own sense of time feel very small. You are tired, perhaps. The day has been long, as days always are when you are paying attention. You have seen the reef in its afternoon light, and its evening transition, and its night character. You have met the Brachiopods and the crinoids and the trilobites and the nautiloids and the fish of many species, and the moray eel and the invisible plankton, and the distant synapsids on the land above. You have felt the warm water of the Permian Sea on your skin. You have breathed the ancient oxygen dissolved in ancient water. Let your body settle a little more into the water. Let the current hold you. You do not need to stay alert. The sea is doing its work around you, and it will do its work whether you are watching or not. The night has many more hours in it, and you are welcome to drift through them as slowly as you like. The bioluminescence continues. The plankton rises. Somewhere on the reef, a crinoid extends its arms into the dark current, and the night deepens, and the world that is ending has not yet ended, and for now, that is everything. If you are drifting now, let yourself go. Subscribe so the next story is waiting when you return. Sleep well. There is a moment in the deep middle of the night when the sea achieves a stillness that is not the absence of life, but the absence of urgency. Everything that is going to hunt has been hunting. Everything that was going to feed has been feeding. The great metabolic transactions of the night are underway, and the pace of visible activity in the water has settled into a slower, more deliberate register. This is the midnight of the Permian Sea, and it is one of the quietest and most complete versions of nighttime that has ever existed on this planet. You have drifted back toward the reef without quite noticing it, drawn by some subtle current or some unconscious navigation in the direction of the nearest warm mass of complexity. The reef is there, a dark shape in the dark water, lit from within in the faintest possible way by the organisms that live on and in it, and that generate their own chemistry in the dark. You are perhaps 5 meters from the nearest coral head, close enough to feel the slight difference in the water temperature immediately adjacent to the reef, where the metabolic activity of millions of organisms generates a warmth that is measurable if not quite perceivable. A nautiloid passes very close to you, much closer than the ones you saw in the afternoon. It is a smaller individual, its shell perhaps 15 centimeters across, and it is moving in a slow spiral through the water column, its tentacles extended in a loose fan around the shell opening. It passes within half a meter of your face, and you can see the eyes on either side of its head clearly in the faint bioluminescent light. The eyes are surprisingly expressive for an animal this ancient. They register the water around them with a quality that is not intelligence in the way you understand intelligence, but is something more than simple reflex. The Nautiloid family is one of the most ancient lineages of complex animal life. Their ancestors were among the top predators of the Ordovician and Silurian seas, enormous coiled shells that dwarfed everything else in the water. The modern nautiloids of the Permian are smaller, more modest, but the body plan is essentially unchanged across hundreds of millions of years. The coiled shell, the siphuncle that regulates buoyancy by adjusting the gas-liquid ratio in the shell's internal chambers, the tentacles, the beak, the remarkable eyes, all of it is the same, or nearly the same, as it was when the first nautiloid-like cephalopod appeared in the ancient seas. This persistence is extraordinary. To survive every mass extinction from the Cambrian to the present, not by radical transformation but by continuing to be what you are in circumstances where almost everything else has been eliminated, requires a combination of characteristics that is very difficult to assemble and very valuable once assembled. The nautiloid's deep-water habits protect it from the disruptions that kill shallow-water animals. Its tolerance for low-oxygen conditions, developed over millions of years of sometimes spending time in less well-oxygenated depths, gives it a margin that other animals do not have. Its long lifespan and relatively slow reproductive rate make it resistant to population crashes. The nautiloid that passed you has continued its spiral and is now above you, its pale underside visible against the slightly lighter water above. It is moving toward the surface, following the nightly migration of the plankton, rising to feed in the most productive layer of the water column before descending again before dawn. It will be fine, this nautiloid, in a way that most of the other animals in this sea will not be fine. Its lineage will persist. Its descendants will be swimming in seas 250 million years from now, their shells changed in minor details, their basic architecture unchanged. They will be something of a mystery to the scientists who study them, an anomaly, an animal that seems to have been built once and never required improving. The reef around you is busy in its midnight way. The moray eel you saw earlier is somewhere in the area, though you cannot see it in the dark. Its chemical trail has been moving through the water, telling the smaller fish and the crustaceans that there is a predator active in this section of the reef, and the smaller animals have adjusted their positions accordingly, withdrawing slightly into the more sheltered parts of the reef structure. This is not conscious strategy. It is chemical communication, the oldest form of communication between organisms, a language made of molecules rather than sounds or symbols. In a crevice about 3 meters to your right, a group of small crustaceans has gathered in a cluster. They came together as the moray eel's chemical signal reached them, an instinctive response to a chemical that means danger, and they are now pressed into the narrowest part of the crevice, their bodies overlapping, their antennae still moving through the water, monitoring the signal's intensity. If the signal increases, they will move further into the crevice. If it decreases, they will eventually disperse again and return to their feeding. They do not know what a moray eel is. They only know the chemical signature of a predator, and they respond to it as they have been responding to similar signals for hundreds of millions of years, because the ones that did not respond this way did not become ancestors. You watch the crustaceans in their crevice without disturbing them. Their antennae move in slow, exploratory arcs. Their compound eyes, which can detect movement but not fine detail, are registering the ambient light of the sea and finding nothing alarming in the direction you are in. You are not a chemical they recognize as a predator. You are an anomaly in their chemical vocabulary, something outside the categories their nervous systems have evolved to pass, and so they do not respond to you at all. You are simply not there in the way that matters to them. The deep water below you is doing something that you can feel only as a very subtle change in temperature. A current of slightly cooler water is moving through the area, coming up from greater depths, carrying with it the chemistry of the deep sea. This is not unusual. Upwelling currents are a normal feature of the ocean's circulation, and they carry nutrients from the deep that fertilize the surface water. But this particular current is carrying, in addition to its normal cargo of nutrients, a slightly higher than normal concentration of hydrogen sulfide, dissolved from the deep sediment where the bacteria have been working in their ancient, patient way. The concentration is still very low, far too low to harm anything in the water column at this depth. The normal chemical buffering of the seawater dilutes it to levels that are meaningless for the organisms you are watching, but it is a signal, a chemical note in the water that, if there was something here capable of reading it, would say, the system is changing. The chemistry is shifting, not fast, not dramatically, but consistently, in a direction that has not been the case for millions of years. The sea is a very large buffer. It takes a great deal to tip it, but tipping is possible. Tipping has happened before. And the molecules drifting past you tonight carry the first faint evidence of a tip that will, eventually, become unmistakable. But you are not that something capable of reading it, and neither is anything else in the sea tonight. There is no organism alive on Earth at this moment that can detect the global shift in ocean chemistry from the chemical signal of a single current. The information exists in the water. The water carries it everywhere. But there is no mind large enough or strange enough to integrate it into understanding, no system of communication between organisms that would allow the message to cross the necessary distances and become warning. The crustaceans in the crevice do not read it. The nautiloid above you does not read it. The moray eel moving through the dark somewhere to your right does not read it. The coral polyps extending their tentacles into the night water do not read it. They only know the chemistry of the immediate present, the single cubic meter of water immediately around them, the chemical signals from the organisms immediately nearby. This is their entire world, and it is enough. It has always been enough. Somewhere far above you, in the atmosphere, over the landmass of Pangaea, the carbon dioxide concentration has risen another small fraction since yesterday, too small to notice in a single day. But since the beginning of the great volcanic episode in what will be called Siberia, the concentration has risen steadily, degree by degree, through the long accumulation of days. The planet is warmer than it was 100,000 years ago, and 100,000 years from now it will be warmer still. And the sea, which absorbs both warmth and carbon dioxide from the atmosphere, is changing its chemistry in response, slowly, as the sea always changes, but changing. All of this is very far from the midnight reef where you are floating. The reef is here. The water is warm. The bioluminescence continues its gentle light show in the water around you. A small fish drifts past, catching the faint light on its scales for a moment, and then it is gone. You breathe, or do the thing that serves breathing in this vision of the ancient sea. The current moves through you. The night continues its deep, unhurried passage. There are still hours before the dawn, hours before the first light, hours of this dark, warm, ancient water. Let them pass slowly. You have nowhere to be. The Permian Sea is the oldest and most enduring experience of the night ocean that you will ever have, and it is yours now, for as long as you want it. Rest. The water holds everything. The night holds the water. And somewhere above all of it, the stars that no human eye has ever seen are doing what stars do, burning without ceasing, caring nothing for the small, chemical drama playing out in the warm shallows of a planet they will never approach. There is a particular quality to the ocean in the hours before dawn, a quality that has no simple name, but that every creature sensitive enough to detect it knows without being taught. It is not simply darkness, because the ocean has been dark for hours. It is not simply coldness, because the temperature changes are gradual and have been underway since sunset. It is something more like a gathered stillness, a suspension, as though the sea itself is holding a long breath before the morning begins. You feel it now, floating in the water, your body relaxed and your breathing slow. The darkness around you is absolute, but it is not empty. It is full of the small sounds and the slight movements and the invisible presences of the night ocean doing its work. The bioluminescence has quieted somewhat in these deepest hours. The most spectacular displays belong to the earlier part of the night, when the predators were active and every disturbance in the water set off cascades of cold blue light. Now the light appears in smaller, more isolated pulses. Here, a single organism disturbed by something passing near it. There, a cluster of tiny planktonic animals settling into a slightly different part of the water column as the currents shift in their slow nocturnal patterns. The darkness between these pulses is very dark, and it is very quiet, and it is very old. What does it mean to be ancient? The reef below you has been growing for millions of years, but individual reefs are temporary. The limestone they build eventually becomes rock, and the rock eventually becomes part of the seafloor, and the seafloor eventually is pushed down into the mantle and melted and recycled into new volcanic material. The individual polyps that are adding their tiny increments to the reef tonight are not ancient. They are very young, most of them, living their brief adult lives before they die and become part of the structure. But the form they represent, the colonial reef-building organism filtering calcium from seawater and depositing it as calcium carbonate, is ancient beyond any individual's reckoning. The corals of the Permian Sea are not the corals of your time. They belong to different orders, different groups with different internal architecture, different relationships with the photosynthetic organisms they carry in their tissues. But the basic principle is the same. An animal, small and soft-bodied, that builds a hard structure around itself using minerals extracted from the surrounding water. This principle has been operating in the ocean since before the Cambrian, in various forms practiced by various groups of organisms. It will continue to operate long after the Permian, though the groups that practice it will change. The form is ancient, the practitioners are temporary. This is one of the things that becomes clear when you spend time thinking about the deep history of life, the distinction between form and practitioner. Evolution does not, in general, invent entirely new ways of doing things. It takes existing approaches and refines them, modifies them, applies them to new situations. The basic tools of life, the cell membrane, the nucleic acid carrying information, the protein doing the work, the metabolic pathways converting energy, these were invented once, billions of years ago, and everything since has been variations on that original theme. New body plans arise, but they are built from old components. New ecologies develop, but they reuse old solutions. The reef-building strategy is one of those old solutions. The filter-feeding strategy practiced by the Brachiopods and the crinoids is another. The predator-prey relationship that drives so much of the reef's daily drama is another. The deep circulation of the ocean that regulates the planet's temperature is another. All of these are very old. All of them will continue, in modified forms, for a very long time after tonight. What will not continue, at least not in their current forms, are the specific organisms that practice these strategies. The tabulate corals and rugose corals that build the Permian reefs will be gone by morning, in geological terms. The brachiopods that are so numerous now, so dominant in the benthic community, will survive, but in greatly reduced diversity, as a remnant group rather than a dominant one. The trilobites, which have been in the ocean since the early Cambrian, 500 million years of continuous presence, will be gone entirely. The ammonoids, some of which have survived earlier crises, will be reduced to a single lineage from which the entire Mesozoic ammonite radiation will eventually spring. The crinoids will survive, though barely. The nautiloids will survive. The sharks will survive. Various lineages of fish will survive. The deep-sea worms and bacteria will be almost unaffected. Life will continue. But the specific configuration of life, this specific community of organisms that has built the Permian Reef over millions of years, this will end. And it will end without any of the organisms involved having any concept of ending. The sea tonight does not know it is ending. This is perhaps the most important thing to sit with. As the hours before dawn accumulate in the darkness around you, the reef is not grieving. The organisms are not afraid. They have no access to the geological record that would tell them what is about to happen, no way to read the chemistry of the deep water as a warning sign, no capacity for the kind of temporal thinking that would allow them to place tonight in the context of what has come before and what is about to come after. They have only the present moment, and in the present moment they are alive, and the sea is their home, and they are doing what they have always done. There is something deeply peaceful in that. Not peaceful in a sad way, not the peace of resignation, but peaceful in a fuller sense, the peace of total presence. The reef is completely present to itself. Every polyp is completely engaged in being a polyp. Every brachiopod is completely engaged in being a brachiopod. There is no division in them between what they are and what they wish they were, no tension between their actual lives and some imagined better life. They are simply and entirely what they are, and they are doing it completely, and in the hours before dawn they are doing it in the dark, and they will continue doing it until they cannot. Your body, floating in the water, is doing something similar. Your heart is beating. Your lungs are breathing. Your cells are processing oxygen and nutrients and making the thousands of small chemical decisions that constitute the maintenance of a living body. None of this requires your attention. None of it requires your direction. Your body knows how to do all of it, and it is doing all of it now, quietly, while you float in the pre-dawn darkness of the ancient sea. You do not have to manage it. You only have to be here. The stars above the surface of the water, invisible to you from below, are at this hour very bright. The Permian sky has no light pollution. There are no cities, no artificial sources of light anywhere on the planet. The stars visible from the Permian coast are the same stars visible now, mostly, because 500 million years is not long enough for the constellations to change significantly, but they are brighter than you have ever seen them, because the atmosphere is clear and the darkness is absolute. From the water's surface, looking up on a Permian night, you would see a sky dense with stars, the Milky Way a broad river of light across the darkness, everything very still and very remote and very old. The stars do not know about the sea below them. The sea does not know about the stars above it, but they are connected, in ways that are real even if they are invisible. The elements in the sea were forged in the cores of earlier stars and scattered through the galaxy by stellar explosions millions of years before the sun formed. The calcium in the shells of the brachiopods, the iron in the blood of the fish, the carbon in every organic molecule, in every cell of every organism in the Permian Reef, all of this was made in stars. All of this was in the gas cloud that collapsed to form the sun and the planets. All of this has been on Earth since the planet formed, cycling through different forms, moving between rock and sea and air and life, and it is here now, organized into the temporary forms that constitute the late Permian biosphere. In a few 100 million years, some of this calcium will be in the bones of mammals walking on the surface of a world that has completely reorganized its continents and its climate. Some of it will be in the shells of mollusks in a sea very different from this one. Some of it will be in the cells of plants covering a land that looks nothing like Pangaea. And some of it, a small amount that has followed a very long and improbable chain of circumstances, will be in you, reading the record of these ancient seas, or listening to it in the darkness before your own particular dawn. The pre-dawn hours deepen. The darkness is at its most complete. The surface of the sea is very quiet, barely any swell, the wind having died in the deepest part of the night. Below the surface, the reef breathes in its slow collective way, each organism doing its individual thing, the whole adding up to something that no individual organism can perceive, but that is real nonetheless. The community, the ecosystem, the interdependence of all these different forms of life on each other, and on the chemical conditions that their combined activity creates and maintains. There is a beauty in this interdependence that is also very old. Every organism in the reef depends on other organisms. The coral polyps depend on the photosynthetic algae in their tissues. The fish depend on the invertebrates they eat. The invertebrates depend on the plankton that rains down from above. The plankton depend on the nutrients cycled by decomposers and on the light that comes from the sun. The sun depends on nothing in the reef, but the reef depends completely on the sun. The chain of dependence goes in every direction, and when you follow any one strand far enough, you end up touching every other strand eventually. You are part of this web too, though your specific connections look different in your time. The oxygen you breathe was produced by photosynthetic organisms, the descendants of the cyanobacteria that first oxygenated the atmosphere 2 billion years ago, and of the algae and plants that continued the work. The food you eat is built from energy originally captured by photosynthesis. The water in your body has been in the sea and in the atmosphere and in glaciers and in rivers countless times before it became part of you. You are woven into the same web as the Brachiopods and the crinoids, just at a different point in the weaving. The sky is beginning to change. From the water, you cannot see it directly, but you can sense the approach of dawn in the slight warming of the surface water, the almost imperceptible increase in the light that filters down from above. The night is ending. The dawn will come, and with the dawn, the last full day of the Permian world will begin. The sky above the Permian Ocean has no human witness. There is no one standing on the coast of Pangaea watching the light change. There is no one sitting on a cliff top with their feet hanging over the edge, watching the horizon go from black to navy to a pale, almost greenish grey that is neither night nor day. The dawn of the last full day of the Permian world happens without observation, as all the dawns before it have happened, and it is beautiful in the absolute way of things that exist for their own sake, and not for any eye. The light comes into the water from above, the same way it always comes, a gradual brightening of the surface that turns the water from black to deep blue, to a lighter blue that begins to show texture and depth in the shadows of things. The planktonic organisms that rose to the surface during the night begin their descent, following the light gradient down to the deeper, darker water where they are safer from the visual predators of the day. The nocturnal animals of the reef begin to withdraw into their daytime shelters. The diurnal animals begin to stir, emerging slowly from crevices, extending tentacles to test the water, beginning the process of waking that the light triggers in anything that uses light as a clock. You have been in the water through the night. Your sense of time is soft and unreliable, the way the sense of time becomes when the usual markers are absent. But the light tells you that the night is ending, and something in you responds to that light, even in this dream of the ancient sea, a gentle stirring toward the surface, toward the warmth and the brightness that the dawn brings. You rise a little. The water above you is already lighter than the water below, and as you rise, the light increases, and the colour of the water shifts through its palette, from the deep blue of the night ocean to the warmer, more golden blue of the early morning shallows. The reef is beautiful in this early light, more beautiful perhaps than it was in the full light of the afternoon, because the dawn light is still coming in at a low angle, cutting through the water horizontally rather than from above, and it catches the surfaces of things differently. The coral heads are lit from the side, their complex surfaces throwing shadows across themselves. The fish that are emerging from their crevices are backlit, their silhouettes crisp against the lighter water behind them. A school of small fish, perhaps 50 individuals, moves through the middle water in the way fish schools move in the early morning, with a slight randomness that will organize into more purposeful movement as the day progresses and their biological systems fully wake. A mantis shrimp emerges from its burrow in the sediment near the base of the reef. It is a spectacular animal, even by the standards of the Permian Reef, which has many spectacular animals. Its body is perhaps 20 centimeters long, striped in green and orange and brown. its appendages complex beyond what you would expect from something so small. The appendages that give it its name can strike with the force and speed of a small explosion, shattering the shells of crabs and snails with a violence that is disproportionate to the animal's size. But right now, it is not hunting. It is in the deliberate, careful process of cleaning the entrance to its burrow, removing particles of sediment with precise movements that suggest a level of behavioral sophistication well beyond what its nervous system would seem to support. You watch the mantis shrimp. It does not notice you, or if it notices you, it classifies you as something too large and too uncertain to engage with. It continues cleaning its burrow entrance with the focused attention of something that knows exactly what it is doing, even if knowing is too strong a word for the process that is happening in its relatively simple nervous system. The burrow is important. The burrow is shelter and home, and the place from which all hunting expeditions depart and to which they return. The maintenance of the burrow is not optional behavior. It is as fundamental as eating. The light is strengthening. The long, oblique shafts of early morning light are giving way to a more direct illumination as the sun climbs above the horizon, wherever the horizon is from your perspective. The colours of the reef are returning to their full daytime richness. The oranges and reds and purples and yellows of the coral animals and the sponges and the fish, all becoming more saturated as the light intensifies. This light will last all day, and then the cycle will begin again. The afternoon will come, the day shift will give way to the night shift. The bioluminescence will begin. The nautiloids will spiral in the dark water. Or rather, this would happen if the system were to continue as it has always continued. But the system is not going to continue as it has always continued. This is the last dawn that will look like this. Not the last dawn in any absolute sense, because the Earth will continue to rotate for another 5 billion years and the sun will rise over it for all of that time. But the last dawn of this particular world, this particular arrangement of species and chemistry and reef and open water and deep sea that has been building for 99 million years, the dawn does not know this. The reef does not know this. The mantis shrimp cleaning its burrow entrance does not know this. The school of fish moving through the early morning water does not know this. They are in the dawn, doing what they do in the dawn, and the dawn is the same as any other dawn, warm and oxygenated, and full of light and food, and the 100,000 urgent small transactions of life going about its business. You know it. You are the only thing in this scene that knows it. And knowing it, you might feel something, some weight of sadness or of awe or of both together, the way those two feelings are often together in the presence of extraordinary things that will not last. But sadness is a heavy thing to carry in warm water in the early morning light, and perhaps what you feel is something quieter than sadness, a recognition, a witnessing. The act of being here, in this moment, in this water, seeing this world in the last hours of its full existence, witnessing is its own form of honouring. The reef cannot witness itself. The coral polyps have no capacity for recognition. The fish school has no awareness of its own beauty. The mantis shrimp cleaning its burrow has no concept of the impermanence of the world it inhabits. Only you, visiting from a time 250 million years in the future, can hold in your mind the whole picture, the world as it is, the ending that is coming, the long recovery that will follow. Only you can see the reef and the fish and the ancient morning light and understand that they are precious, not in spite of their impermanence, but partly because of it. Impermanence does not diminish beauty. If anything, it deepens it. The brachiopod that has been filtering the water for 3 years, the trilobite resting in its crevice, the great reef community stretching in both directions along the coast, all of it is beautiful, precisely because it exists now, and because its existence is not guaranteed. Nothing is guaranteed. The universe does not promise continuity to any specific configuration of matter. It only allows configurations to exist for as long as the conditions that support them persist, and when the conditions change, the configurations change too, and something new arises. The morning deepens. The early light becomes the full light of day. The reef is fully awake now, the day community in full operation, the night community withdrawn to its shelters. A large parrotfish-like animal moves along the reef face, taking bites of coral with its fused teeth, grinding the coral into sand with the powerful muscles in its throat. extracting the algae that lives inside the coral polyps before excreting the sand in a long, pale cloud that drifts down to the seafloor. This is one of the reef's essential processes, the recycling of calcium carbonate through the bodies of organisms, the constant construction and deconstruction that keeps the reef architecture dynamic rather than static. You are in the full light of the last morning. The water is warm and clear and golden with the morning sun. The reef is alive in all its dimensions. The fish are moving in their schools and their solitary patrols. The invertebrates are doing what they do. The deep water below you is doing its slow chemical work. The land above the sea is continuing its separate life. The synapsids and the amphibians and the insects going about the business of the Permian day in the forests and the deserts and the coastal margins of the great continent. And somewhere, very deep, in the basalt provinces that will one day be called Siberian, the lava is still flowing, has been flowing for hundreds of thousands of years, will continue to flow for hundreds of thousands more. The gases it releases join the gases already in the atmosphere. The concentration of carbon dioxide continues its slow, inexorable rise. The planet continues to warm, and the chemistry of the ocean continues, molecule by molecule, to shift. But for now, the morning is the morning, and it is beautiful. Imagine, for a moment, a place you cannot see from here. Imagine travelling across the surface of Pangaea, from this warm coastal sea northward, crossing the equator, and then continuing north through zones of increasing aridity, through the great desert heart of the supercontinent, through mountain ranges and river valleys and vast plains of red rock, until you reach a region that is even more remote than what surrounds it, a northern province of Pangaea that will one day be covered by the forests of Siberia, but that right now is a landscape of rock and shallow lakes, and sparse vegetation pressed down by the weight of a climate that is cold in winter and not much warmer in summer. In that landscape, in certain places that appear ordinary from the surface, the ground is warm underfoot, not hot, not dramatically warm, just a degree or two above what the surrounding rock would be, a warmth that bleeds upward from below through the long columns of rock that make up the crust. And in certain places, cracks in that crust have opened, and from those cracks, lava has been flowing. Not continuously. In episodes, with years or decades between them, as the pressure builds and releases and builds again. But the episodes have been recurring for hundreds of thousands of years, each one adding more basalt to the surface, more carbon dioxide to the atmosphere, more sulfur compounds to the air and the water. This is the Siberian traps. Traps from a Scandinavian word meaning stairs, because the lava flows have accumulated in stair-like terraces that are visible in the geology of the region for millions of years afterward. It is one of the largest volcanic provinces that will ever exist on this planet, covering an area roughly the size of modern Australia with lava, building up in layers over hundreds of thousands of years, until the cumulative depth in some places is several kilometres. The sheer scale of it is difficult to hold. The volume of lava produced by the Siberian traps eruptions is estimated at somewhere between 1 and 4 million cubic kilometres. This number is almost meaningless until you begin to compare it to things you know. The largest volcanic eruption in recorded human history, the 1,815 eruption of Tambora in Indonesia, produced perhaps 160 cubic kilometres of material and caused a global temperature drop significant enough to trigger a year without summer in the Northern Hemisphere. Crop failures, famine, and widespread death across Europe and North America. The Siberian traps produced 10,000 times that much material, spread over a longer period, but concentrated enough to change the atmospheric chemistry of the planet in ways that no single eruption could. The carbon dioxide released by the eruptions has been accumulating in the atmosphere for a very long time, but the carbon dioxide from the lava itself is not the whole story. Perhaps more significant is what happens when that lava flows over the surface rocks of this particular region. The rocks of Pangaea's northern province are not ordinary rocks. They include enormous deposits of coal and oil shale and carbonate sediments that formed during the Carboniferous period, when the great swamp forests died and their carbon was locked into the ground. When the lava flows over these deposits, it cooks them. The organic carbon in the coal is converted to carbon dioxide and methane. The carbonate minerals release carbon dioxide as they decompose under heat. The sulfur in the coal and oil shale becomes sulfur dioxide, which reacts with water vapor to form sulfuric acid droplets in the upper atmosphere. All of this chemistry is happening right now while you float in the warm shallows of the Permian Sea. Far to the north, invisible, the lava flows are adding their chemical signature to the atmosphere, molecule by molecule, in quantities that the ocean and the land biosphere can absorb and neutralize for a while, and then cannot. The tipping point, the moment when the accumulated gases begin to overwhelm the system's capacity to buffer them, has been approaching for hundreds of thousands of years, and it is very close now. How does a system reach its tipping point? The question is one that scientists will spend a great deal of time on in the distant future, trying to understand not just the Permian extinction, but the more general dynamics of systems under stress. A system under gradual pressure can appear stable for a long time, absorbing the pressure and returning to equilibrium after each disturbance. The response of the system to each unit of pressure is linear, and the system seems robust. But beneath the surface, certain thresholds are approaching. Chemical concentrations reach levels where certain organisms begin to fail. The loss of those organisms changes the chemistry in ways that accelerate the pressure on others. A cascade begins, slowly at first, and then faster as each failure removes a buffer that was holding back the next failure. The Permian Ocean has been absorbing carbon dioxide from the atmosphere for a very long time. The ocean is, in fact, one of the planet's primary carbon sinks. Its chemistry evolved to capture carbon dioxide from the air and use it in the formation of calcium carbonate shells and skeletons. The organisms of the reef are doing this right now, every one of them with a calcium carbonate structure incorporating atmospheric carbon into their bodies and into the rock of the reef below. The ocean also absorbs carbon dioxide directly into the water, where it reacts with the water to form carbonic acid, and the carbonic acid is buffered by the calcium carbonate of the sediment and the shells and the rock. But there are limits to this buffering capacity. As more and more carbon dioxide enters the water, the pH of the water drops, becoming slightly more acidic. A slightly more acidic ocean makes it harder for organisms to build their calcium carbonate structures. At some threshold of acidity, building becomes impossible, and the organisms that cannot build their structures cannot survive. The reef corals, the brachiopods, the nautiloids with their elegant coiled shells, the echinoderms with their calcite skeletons, all of them require a certain minimum pH in the water to maintain their chemistry. Below that minimum, they dissolve. The ocean's pH has been dropping, very slowly, for a very long time. The change is so gradual that no individual organism has experienced it as change. Each generation was born into a world where the chemistry was slightly different from the world their ancestors were born into, and they adapted, or their species adapted, to conditions that were slightly more acidic than what their ancestors experienced. But each generation was also slightly less able to build its calcium carbonate structures than the previous generation. The shells of brachiopods are slightly thinner than they were 100,000 years ago. The coral skeletons are slightly less dense. These changes are below the threshold of anything any organism can detect or respond to. They are changes in the statistics of populations, not in the experience of individuals. The changes are real, though, and they are cumulative. And the direction they are moving in is the direction of conditions that the organisms of the Permian Reef cannot survive. You are floating in the warm, clear water of the last morning of the old world, and none of this is visible to you any more than it is visible to the brachiopod, or the trilobite, or the sea lily. The water around you is still warm and oxygenated and full of life. The reef is still building. The fish are still moving. The chemistry of the sea is still within the range of normal, if right at the edge of the range where it has always been. But 12 hours from now, in certain parts of the deep ocean, the first toxic layer will reach a threshold where the animals there begin to die in significant numbers. Not here, not in the shallows, not yet. The shallows will hold on longer than the deep, because the surface ocean is still in contact with the atmosphere and still receives oxygen from the air, but the deep water has no such contact. The deep water depends entirely on the circulation from the surface, and that circulation is slowing as the ocean warms and the temperature difference between the poles and the tropics decreases. As the circulation slows, the deep water becomes more anoxic, and as the deep water becomes more anoxic, the hydrogen sulfide in the sediment has nowhere to go but up. None of this prevents the morning from being beautiful. The morning is beautiful without reservation, as all mornings are. The light on the water is the same light it has always been, the same ancient photons from the same young star, falling on the same chemical processes that life has been running since the beginning of its existence. The beauty is not lessened by what is coming. If anything, it is deepened. You float in it. You breathe in it. You let the morning light on the warm Permian Sea be exactly what it is. The reef is below you and around you, breathing in its ancient way, doing what it has always done. The world is fully itself, right up to the last moment. That is perhaps the most important thing to remember about it. The sun is high. The Permian sun of the last afternoon of the world, as these creatures know it, high in the sky of a planet that has not yet seen a human face, shining down on a sea that is 252 million years old in its present form, its warmth reaching through the surface and filtering down through the water column in the long vertical shafts that characterize midday in the tropics. The water is at its warmest right now. The reef is at its most active. The fish schools are moving in their complex choreographies through the illuminated water. The Brachiopods have their shells open to their widest extent, maximizing the volume of water they filter in the productive midday conditions. You are at the surface now, or very close to it. You can look up and see the underside of the waves above you, the constantly shifting interface between the sea and the air, a plane of light and motion that has no exact location, only a general altitude. The light here is intense and warm, so warm you can feel it the way you can feel sunlight through a car window, a radiant warmth from above that adds to the warmth of the water around you. The surface of the Permian Ocean, in the tropical latitudes near the equator, is among the warmest water on the planet, averaging temperatures that are perhaps a few degrees higher than the warmest modern tropical seas. This warmth is one of the things that makes the Permian reef community so diverse. Warm water supports higher rates of metabolic activity in the organisms that live in it, which supports faster growth and faster reproduction, which supports higher densities of organisms and more complex food webs. The Permian tropics are a hothouse of life, an engine of biological productivity that has been running at high speed for millions of years, and that looks, from the inside, like it has no intention of slowing down. Look at the water around you right now. Look at the density of life in it. There are fish visible in every direction, from the largest ones 30 or 40 centimeters that move with the confidence of established predators, to the smallest ones a centimeter or two that hover in dense clouds near the coral surface, feeding on the microscopic organisms that coat every surface of the reef. There are invertebrates everywhere. A large echinoderm, a relative of the sea urchin but shaped differently, moves ponderously across the top of a coral head, its tube feet gripping the coral surface with careful precision. A group of cephalopods, smaller than the nautiloid you saw the night before, jet through the water in coordinated pulses, moving from one part of the reef to another in a formation that is almost architectural. Below the fish and the larger invertebrates, coating every surface of the reef in a layer that is often invisible to casual observation, is the community of organisms that makes all of this possible. Algae, photosynthesizing in the warm light, producing the organic carbon that ultimately feeds everything else. Bacteria, processing nitrogen and phosphorus and sulfur into forms that the algae and the corals can use. Microscopic grazers, eating the algae and being eaten in turn. The invisible foundation of everything visible. This is the thing about ecosystems that is difficult to communicate in a way that lands with the weight it deserves. The impressive parts, the parts that draw the eye, the large animals and the bright corals and the dramatic behaviors, are not the foundation, they are the surface. The foundation is invisible, made of organisms too small to see, running on chemical reactions that require no light and no oxygen, and no complexity of behavior. The foundation is ancient beyond the age of the reef, ancient beyond the age of the Permian, ancient in a way that makes the history you are floating in feel recent. Bacteria have been on this planet for 3.5 billion years. They were here before the oceans had oxygen. They were here before the Cambrian explosion of animal life. They were here before the first coral built the first reef, and they will be here after everything visible in this sea has been eliminated. The extinction event that is coming in the next 12 hours will kill 96% of marine species, but the bacteria will not be among the 96%. The bacteria will persist through the extinction and through the long recovery period that follows, and through every subsequent extinction, and they will be present in every ocean of the planet 252 million years from now, doing the same chemical work they are doing right now in this warm, midday Permian water. There is something equalizing about this. The bacteria do not know they are foundational. They do not know anything, in the cognitive sense. But they are foundational nonetheless, and their persistence through every catastrophe the Earth has faced is a kind of testimony to the durability of simplicity. The complex things, the beautiful things, the things with eyes and nervous systems and behaviors that look almost like intention, these things are the brilliant surface of a very deep, very ancient structure. And the ancient structure endures. A barracuda-like fish moves through the water near you, long and lean and muscled, its body built for speed in the way a good knife is built for cutting. It has been patrolling this section of the reef for most of the morning, moving back and forth along a route that covers the same territory repeatedly, the way many territorial fish do, maintaining familiarity with the space and checking for the presence of prey. It has not been particularly successful this morning. The smaller fish are alert and fast, and the reef provides many more hiding places than any open water predator can easily account for. But now it has spotted something. A small fish, slightly out of position, slightly too far from the nearest coral head, slightly exposed. The predator's response to this is not deliberate strategy in the way human strategy is deliberate. It is a cascade of chemical and electrical signals in a nervous system calibrated over millions of years for exactly this kind of detection and response. The fish turns, it accelerates. The smaller fish is not fast enough. And then it is over, as quickly as it always is, a flash of movement and a disturbance in the water and one fewer small fish in the Permian Sea. Life continues without missing a beat. The other small fish that witnessed the event from behind their coral have already moved back into the open water. The large fish has swallowed its meal and resumed its patrol. The water has smoothed over the disturbance. The reef goes on, as it always goes on, incorporating each individual death into the great cycle of materials and energy that is its fundamental process. The afternoon is beginning. You can tell because the light is shifting again, the direct overhead light giving way to the slightly more oblique angle of the afternoon sun, the water catching the light differently on different surfaces, the shadows on the reef changing their orientation. The fish schools have moved to a new position since the morning, their collective algorithm having processed the morning's information and produced a new distribution that takes advantage of the current food availability. You drift with the afternoon current, which has picked up slightly since the midday calm. The current is warm and has a faint salinity that you can almost taste, the characteristic chemistry of this ancient sea, the specific mixture of dissolved minerals that has been building in the ocean since the first rains fell on the first rocks and carried the first dissolved minerals down to the first sea. The ocean has been concentrating these minerals for billions of years, and its specific chemistry is as unique to this period as the specific species that swim in it. The afternoon is long in the Permian, as afternoons are long when you are paying attention. The sun moves more slowly in its arc than it will in your time, because the Earth rotates more slowly, and the day is longer, and the afternoon extends through more degrees of the sun's arc before evening arrives. There is time. There has always been time here, in the Permian Sea, in the 99 million years of its existence. Time is the one resource that has never been scarce, until now. In 12 hours, the chemistry of the deep water will cross a threshold that it has never crossed before in the Permian seas. The animals that live there will begin to die. The dying will release more organic matter into the already stressed system, accelerating the bacterial activity that produces the toxic gases, and the anoxic layer will rise higher in the water column. It will take years. It will take decades. The full catastrophe will unfold over thousands of years, but the threshold is 12 hours away. The afternoon is warm. The reef is alive. The water is exactly itself. And the time that remains is the most precious kind of time, the kind that is fully inhabited. The question of survival is one of the most interesting questions in the history of life, not because survival is surprising, but because of who survives and who does not. The patterns of extinction and survival in the geological record are not random, but they are also not what you might predict if you were designing a system to preserve what seems most valuable. The largest organisms do not tend to survive mass extinctions. The most complex ones do not either. What survives, again and again, is the small, the flexible, the unspecialized, the thing that can eat almost anything and live almost anywhere, and reproduce quickly enough to fill the empty spaces before something else does. In the Permian extinction, the survivors will be a collection of organisms that, if you were a naturalist of the late Permian, you might not have given much attention to. The nautiloid that is somewhere out in the open water tonight following its ancient patterns of feeding and migration, will survive. Not this individual nautiloid, perhaps, but its lineage will carry through, reduced in diversity, battered in numbers, but alive. The nautiloid body plan, the coiled shell, the chambered interior, the jet propulsion, the intelligence sufficient to navigate the open ocean, will persist, and it will persist for a very long time. The nautilus of your time is a direct descendant of creatures very much like the nautiloid out there in the Permian dark. The sharks will survive. They have already survived one mass extinction, the one at the end of the Devonian, and they will survive this one. The shark body plan is, apparently, difficult to improve upon. It has been doing what it does, cruising the ocean, hunting by electroreception and smell, reproducing slowly but reliably. For 400 million years. It will continue for a very long time after the Permian. The sharks in the oceans of your time carry their lineage back to these Permian seas, unbroken. The Brachiopods will survive, though diminished. From their current position of abundance and diversity, with hundreds of species filling every available role in the benthic community, they will be reduced to a handful of lineages occupying marginal niches in cold water environments. They will not recover to their Permian dominance, but they will survive, and some of their lineages will persist to your time, living relics of the Paleozoic world, found in deep cold water on the margins of the Pacific and in certain fjords, unchanged enough that scientists who first found them alive thought they were seeing ghosts. The crinoids will survive, barely. They will be reduced to a small number of lineages, and they will take millions of years to diversify again. But they will diversify again in the Mesozoic, becoming abundant on the reefs and seafloors of the Triassic and Jurassic and Cretaceous. And some of them will make it all the way to the present, still filtering the water with their feathery arms in the same way they are doing it now tonight on the flanks of the Permian Reef. The fish will survive. Not all lineages and not all species, but the basic vertebrate architecture, the backbone and the gills and the fins, and the increasingly sophisticated brain, will carry through. From the survivors of the Permian extinction, the fish fauna of the Mesozoic will be rebuilt, and from the Mesozoic fish, the modern fish fauna will eventually develop. The oceans will be full of fish again within a few million years of the extinction. Different fish, new species from surviving lineages, but recognizably fish. On land, the survivors will be a different collection. The dicynodonts, those solid and methodical synapsid herbivores, will carry through, reduced in diversity but persistent enough to be among the first large herbivores to recolonize the Triassic world. A single lineage of them, the Lystrosaurids, will become so numerous in the early Triassic that paleontologists sometimes call it the age of Lystrosaurus, a time when one genus of medium-sized dicynodont may have accounted for a majority of the large terrestrial vertebrate biomass on the planet. From such a narrow bottleneck, the diversity of later eras will eventually grow. The small synapsids, the ones that are tonight hunting insects in the leaf litter of the Permian coastal forests, the ones that will eventually become the mammals, will survive. They are already, in the late Permian, more mammal-like than any other living thing. They have differentiated teeth, incisors for cutting and canines for holding, and cheek teeth for chewing, something no reptile has. Some of them already have the beginnings of a secondary palate, the structure that allows a mammal to chew and breathe at the same time, an important innovation for an active, warm-blooded animal. Some of them probably have hair, or at least proto-hair, though hair does not fossilize well and the evidence is indirect. These small animals burrowing in the dark soil beneath the Permian forests will inherit a world that the great gorgonopsids and the huge dicynodonts and the elaborately structured ecosystems of the late Permian cannot survive. They will inherit it not because they are better, exactly, but because they are smaller, and because smaller things need less food and can hide in smaller spaces and can reproduce fast enough to outlast a catastrophe that kills the larger things around them. From these small survivors, from this narrow, improbable remnant of the enormous diversity of the Permian land fauna, will come the entire subsequent history of the mammals. The Triassic mammals, small and nocturnal, living in the shadow of the archosaurs that quickly came to dominate the post-extinction world. The Jurassic mammals, slightly more diverse, still small, still mostly nocturnal, still defined by the constraints of living alongside the increasingly impressive dinosaurs. The Cretaceous mammals, beginning to diversify their diets and their body plans, still mostly small, still mostly humble. And then, 66 million years from now, another mass extinction, another catastrophe, and the mammals suddenly inheriting a world that the dinosaurs dominated for 160 million years, and expanding into it with an evolutionary speed that produces, among other things, the animal that is floating in the Permian Sea tonight, remembering its ancestry. You are the end of that chain. Or rather, not the end, because the chain continues, but a point in it, a temporary form that contains in its cells and its skeleton and its biochemistry all the information accumulated over 4 billion years of biological experiment. You breathe air that was made breathable by cyanobacteria. You have a backbone that was first developed in the Cambrian. You have jaws that evolved from gill arches in the Devonian. You have limbs that are modifications of fish fins. You have a brain that is a continuation of the nervous system first developed in the worms. You are, in a real and specific sense, a continuation of the Permian Sea. The nautiloid out in the dark water tonight is also a continuation of itself. It will carry its lineage forward through 500 million years from the Cambrian to the present, barely changed in its external architecture. A continuity so long and so faithful that it challenges any simple idea of evolution as constant transformation. Some things, apparently, find a form that works and stay in it. Some things become classic, but the classic forms require a particular ocean to sustain them. They require oxygenated water and the right temperature and the right chemistry and an abundance of prey and the absence of the particular chemical that, in the deep water somewhere beneath you right now, is beginning to accumulate at rates that have never been recorded in this ocean before. The classic forms of the Permian Ocean are classic for this ocean, for these conditions, and the conditions are going to change. You do not know exactly when. No one does, not even now, looking back at the geological record with all the tools of modern science. The Permian extinction was not a single event but a process, spread over somewhere between 10,000 and 200,000 years, depending on how you measure it and which part of the record you are reading. In geological terms, this is instantaneous. In biological terms, it is a very long time, many generations for most species, long enough for some populations to shift their ranges or their behaviors in response to changing conditions, long enough for some lineages that look doomed to find temporary refugia, long enough for the disaster to be not a wall but a slope, but it is a slope with a cliff at the bottom. And the bottom is approaching. Not tonight, not tomorrow. Not even, perhaps, within the lifetime of the individual organisms currently alive on this reef, but approaching. The chemistry is changing. The temperature is rising. The deep water is shifting. And the organisms going about their ordinary lives tonight, doing what they have always done, being exactly what they have always been, have no way to know this. There is something in that worth accepting. The ending comes to all things, in one form or another. The individual organism, the species, the ecosystem, the ocean configuration, the continent arrangement. Nothing persists forever in its current form. What persists is the pattern, the information, the hard-won biological knowledge that the surviving lineages carry forward into the next configuration of life. The sea will change. What carries forward will become the seed of what comes next. And what comes next, eventually, is you, floating in the dark water, breathing, present, a temporary form containing a very long history. The reef below you continues, the Brachiopods continue. The Nautiloid continues in the open water, the deep bacteria continue in their ancient work, and the night continues toward its end. The afternoon has become the evening. There was no particular moment of transition, only the gradual process of the light shifting from its midday directness to the oblique angles of late afternoon to the long, warm, amber light that is evening in the tropics. The water has absorbed this light and translated it into a warmth that is still present, though the surface is beginning its slow overnight cooling, the warmth that accumulated during the day beginning to radiate back toward the sky, in the way water always returns, what the sun gave it. You are still here. You have been here all day, from the amber of yesterday's afternoon through the dark of the night, through the dawn and the full light of the day, and now into this second evening, and the Permian Sea is still exactly what it was when you arrived. It has not changed in any way you can measure. The reef is the same reef, the fish are the same fish. or others indistinguishable from them. The Brachiopods and the trilobites and the crinoids and the nautiloids are all still here, still doing what they do, still constituting the complex, balanced, astonishingly productive world that has been building for 99 million years. The change that is coming will not arrive tonight, not in any way that is visible or dramatic. What happens over the next 12 hours is a threshold crossing in the deep water, a chemical tipping point in a zone you cannot visit and the organisms of the reef cannot reach. The reef itself will continue for some time after this threshold is crossed. The full impact of the extinction will take thousands of years to play out, and during those thousands of years the reef will continue to exist, though it will be dying, species by species, each one reaching its individual threshold of tolerance and failing to survive past it. The last Permian reef, whenever it finally ceases to exist as a functioning ecosystem, will not look like the reef you are floating above right now. It will be a diminished thing, its most sensitive species already gone, its structure maintained by only a fraction of the organisms that currently inhabit it. The water around it will be warmer and more acidic, and less oxygenated than what you are floating in now. The fish will be fewer, and the invertebrates sparser, and the overall sense of the place will be of something that is continuing by habit rather than by vitality, the way things sometimes continue by habit long after the conditions that sustain them have passed. But that is not this. This is the last full evening of the fully vital world, the last full evening before the threshold is crossed, and it is beautiful in the way that only a world at the height of its powers can be beautiful. The evening light is doing its work on the reef, turning the colours rich and deep the way it always does, the oranges more orange and the reds more red, and the purples taking on a depth that daylight does not quite give them. A sea turtle-like creature passes overhead, heading for the surface to breathe, its silhouette dark against the lighter water above, its movements unhurried and deliberate. Watch it rise. Watch the long, slow strokes of its flippers carrying it upward through the water, the angle of its body adjusting as it approaches the surface, the slight expansion of the water ahead of it as it displaces the surface layer and emerges into the air above. You can imagine the exhalation, the brief contact with the atmosphere, the inhalation, and then the descent again, the animal angling back down into the water, returning to the three-dimensional world of the ocean with the ease of an animal that has been doing this its entire life, that was born knowing how to do this, that will continue doing this until the ocean no longer supports what it needs to eat. The last of the day's light is in the western sky, which you can infer from the angle of the last light shafts coming through the water. These shafts are long and almost horizontal now, the light coming from so close to the horizon that it travels through a great thickness of atmosphere before reaching the water, and this thickness of atmosphere filters out the blue end of the spectrum and leaves only the orange and red, and the water is suffused with these warm colours in a way that makes the whole sea feel like it is being lit from within by something warm and ancient. The evening shift is in full progress. The day animals are withdrawing to their crevices, the night animals are emerging. The moray eel is already out of its den, moving along the reef wall with the boneless efficiency of its kind, tasting the water with its chemoreceptors, learning what the evening has brought. The crinoids are fully extended into the evening current, their arms tracing their slow arcs in the enriched flow that the afternoon's warming and the evening's beginning cooling have stirred up. The plankton is beginning its nightly migration upward. There is a moment in the transition between the day reef and the night reef, when both communities are partially active simultaneously, and the density of visible life in the water is at its highest. That moment is this moment. Every crevice in the reef has an animal either emerging from it or withdrawing into it. The water column between the reef and the surface is full of fish moving in both directions, the day fish going down and the night fish coming up. The invertebrates on the reef surface are in various states of transition, some fully active, some beginning to retract, some already retracted. You could stay here forever in this moment. The Permian Sea in the transition between day and night is one of the richest, most alive moments in the history of this ocean, and you are present in it, floating in the warm amber water of the last evening, watching the handover between two communities that have been doing this handover every single day for millions of years. The reef does not know this is the last. The fish do not know. The moray eel navigating the evening waters does not know. The brachiopod, its shell open in the final warmth of the day, does not know. The trilobite in its crevice does not know. The nautiloid, beginning its nightly ascent from the deeper water, does not know. They know only the evening, and the evening is the same as every other evening. The chemistry of the water is the same as yesterday's evening. The temperature is the same. The oxygen content is the same. The fish are the same. The coral is the same. The reef is the same, right up to the moment when it is not the same, and that moment is not yet. That moment is in the deep water. Hours from now, below the reach of this evening's beautiful amber light. Let yourself be here. Let yourself stay in this warm amber, ancient evening, in the water that has been this particular water for 99 million years, in the company of these organisms that have built this world over all that time. The evening is long, the light is warm, the current is gentle, the reef breathes in its ancient way. You do not need to witness the ending. You only need to be here for the life, and the life is here, fully, in this moment, in this warm and ancient and irreplaceable world. It is enough to have been here. It is more than enough. To have floated in this sea, to have watched the fish and the crinoids and the brachiopods and the nautiloids and the ancient shark moving along the base of the reef, to have experienced the bioluminescence of the midnight ocean and the dawn of the last morning and the full light of the last day, and now this amber evening, this is more than most witnesses of Earth's history have ever had. The water holds you, the reef is around you. The evening light is warm and golden and almost gone. The night is coming, and you, if you are willing to let it, will drift with the coming night into a sleep that is as deep and as old as the sea you are floating in. Let the warmth of the Permian water be the warmth around you now. Let the gentle current be the air in the room where you are lying. Let the long, slow rhythm of the ancient waves above be the rhythm of your breathing. Let yourself go down, as the nautiloid goes down, as the plankton descend before the dawn, into the quiet dark where the deep water waits. Let the water hold you now. This is what water does, and has done, for as long as there has been water and things living in it. It holds. It supports. It presses in from every direction with the gentle, even pressure of its weight. And in that pressure there is something that resembles being held by something very large and very patient. The ocean has been here for 4 billion years. It has held trilobites and jellyfish and the ancestors of fish and the fish themselves and the ancestors of land animals and everything that lives in the sea tonight. It is good at holding. It has had a long time to practice. Your body is relaxing now. You may feel it in the muscles of your shoulders, which have been carrying a tension you did not notice until it begins to release. You may feel it in your jaw, which unclenches slightly as your breathing deepens and slows. You may feel it in your hands, which open a little, the fingers uncurling from whatever unconscious grip they maintained through the waking hours. The body knows how to let go. It only needs permission, and the right conditions, and the right kind of attention to itself. The Permian Sea tonight is the right kind of attention. The water is warm, precisely the temperature that the body finds neither too hot nor too cold. The temperature at which the distinction between your skin and the water around you begins to soften. The darkness removes the demands of vision, the constant small work of tracking and interpreting the visual world. The stillness removes the demands of sound, or rather reduces them to the few sounds that are not demands at all but simply presences. The low and rhythmic movement of the water, the occasional distant sound from somewhere in the reef, the near silence of the open ocean at night, breathing in, breathing out. This is the oldest rhythm. The first organisms that developed the capacity to exchange gases with their environment were doing something that is continuous with what you are doing now, drawing in what you need and releasing what you do not. Your lungs, which are the product of hundreds of millions of years of refinement from the first swim bladders of primitive fish, are doing their work without any instruction from you. The oxygen dissolves into your blood. The carbon dioxide is carried back and released. The transaction happens, as it always happens, as it has always happened. Below you, the reef is settling into its nighttime rhythms. The fish that feed by sight have found their resting places, hovering motionless in crevices or beneath the shelter of coral formations, their metabolism slowed to the minimum necessary to maintain life. The creatures of the night are moving in the dark, the ones with chemical senses rather than visual ones, following trails of dissolved compounds through the water to find their food. The reef at night is quieter than the reef by day, but it is not still. Nothing in the ocean is ever entirely still. The brachiopods on the reef surface are doing the same thing they do every hour of every day. Their valves open to the current. The water moves through the lophophore. The particles are captured and moved toward the mouth. The water exits. It is a continuous process, not a rhythmic one in the way that heartbeats are rhythmic. Not a pulse, but a flow, uninterrupted, patient beyond any human conception of patience. The brachiopod does not decide to filter the water. It simply is the kind of thing that filters the water, and so it does, because that is what it is. The crinoids on the reef are doing the same. Their feathery arms spread to catch whatever the current brings. A crinoid arm, seen up close, is a remarkable structure. Each pinnule, each tiny feather branch, is covered with smaller structures called tube feet, and each tube foot is equipped to capture particles and move them toward the central groove that runs the length of the arm to the mouth at the center of the flower-like head. The mechanism is intricate and precise, and has been operating in various forms since the Ordovician, 400 million years, and more of water filtering in the shallow seas of the world. There are deep-sea creatures below you now, below the depth at which you float, below the reach of the bioluminescence, and below the reach of any light that filters from the surface. These creatures exist in a permanent darkness, and they have adapted to it in ways that are sometimes startling in their inventiveness. Some of them produce their own light, using bioluminescent lures or patterns to attract prey or communicate with others of their kind. Some of them have enormous eyes, adapted to detecting the faintest traces of bioluminescence in the darkness. Some of them have given up on eyes entirely and navigate entirely by chemical and pressure sensing. The deep sea is cold. The cold is a constant, not a seasonal thing or a daily thing, but a permanent feature of the deep, where the sun's warmth does not reach. The organisms adapted to this cold are adapted to it completely, unable to survive in the warmer, shallower water, as tied to their particular conditions as the reef animals are tied to theirs. The deep sea has always been cold, will always be cold, regardless of what happens at the surface. It is one of the most stable environments on the planet. But even the deep sea is changing tonight, in ways too subtle for any of its inhabitants to detect. The oxygen content of the water in certain deep basins has been declining for tens of thousands of years, driven by the warming of the surface water, which reduces the efficiency of the ocean's circulation. Warm water holds less oxygen than cold water. Warm water is less dense than cold water, and so it sits on top rather than sinking to replenish the deep. The turnover of the ocean slows. The oxygen that deep-sea animals depend on becomes slightly less abundant with each passing millennium. The animals in the deep tonight are doing what they have always done, unaware that the chemical composition of their world is shifting. They are hunting and being hunted, feeding and being fed upon, living their brief lives in the darkness at the bottom of the ancient sea. They do not know that the margin between their world and an uninhabitable one is narrowing. They do not have the capacity to know this. They are simply alive, in the way that only the present allows anything to be alive. Your breathing has slowed. Your body is heavy in the water. The distinction between being awake and being asleep is beginning to soften. The way the distinction between your skin and the water has softened. The thoughts that occupied you before you came to float in the Permian Sea are becoming less insistent. They are still there, perhaps, but they are farther away, like sounds from another room, present but not demanding your attention. The reef below you continues. You can feel the slight movements in the water that tell you it is alive, the tiny currents produced by the bodies of thousands of organisms going about their ancient business. The water carries these movements to you, and you receive them without effort. The way the brachiopod receives the particles in the current, not choosing them, not directing them, simply open to what arrives. In the deep water below the reef, in the water below the light, in the sediment below the water, the chemistry is doing what chemistry does, following its laws without reference to the life that depends on it. The gases accumulate, the minerals precipitate, the organic compounds are broken down and rebuilt. The ancient processes continue, as they have continued for longer than life has existed, as they will continue long after the specific configuration of life on the surface has ended and been replaced and ended again. You are floating on all of this, on the ancient sea, on the ancient chemistry, on the ancient patterns of the ocean's circulation and the ancient rhythms of the tides. The moon that pulls the tides is the same moon that will pull them in your time, only slightly farther away because the Earth-Moon system is slowly evolving, the moon moving fractionally outward with each passing year. But the tides are the tides, the pull is the pull. The ocean rises and falls as it has always risen and fallen. Let yourself fall now with the tide's withdrawal. Let the weight of the day leave you, the weight of the week, the weight of the small accumulated frictions and concerns that constitute the ordinary business of being a person in the world. None of those things are here. This is the Permian Sea. This is 252 million years before your concerns were possible. The trilobites do not know your name. The Brachiopods do not know your worries. The Permian Ocean holds everything that is here without judgment, without memory, without expectation. It holds you the same way, with the patient, even pressure of its depth, with the warmth that is precisely the warmth your body needs, with the darkness that asks nothing of your eyes, with the quiet that asks nothing of your ears, with the gentle rocking that asks nothing of your mind except that you be here, floating, for as long as you need to float. The night continues, the reef continues. Your body, heavy and warm and completely supported, continues its ancient business of being alive. And you, the part of you that is reading this, begins to release its grip on the waking world and descends, like a particle of organic matter settling slowly through the water column toward the quiet bottom of sleep. There is a creature on the land above this sea that you should know about, not because it is dramatic, not because it is the largest or the most fearsome animal in the late Permian world, but because it is the one whose lineage matters most to the story of everything that comes after. It is a small animal, smaller than you might expect for the ancestor of everything you know, perhaps the size of a large rat. Its body is covered in scales, as all Permian land animals are, though in certain subtle ways the scales of this particular lineage have already begun a transformation that will eventually result in something very different from scales. Its four legs are beneath its body, not sprawled to the sides the way the legs of most Permian reptiles are arranged, and this gives it a slightly more upright posture than its relatives, a posture that allows it to move more efficiently and to breathe more easily while moving. It is out now, in the late afternoon above the coastal rocks. It has been resting in a crack in the limestone during the hottest part of the day, as it always does, retreating from the surface heat into the cooler microclimates of the rock's interior. Now the temperature has dropped enough that it is comfortable to be active, and it is moving through the rock debris at the base of a cliff with the quick, purposeful energy of a small animal that knows it is vulnerable and must be efficient with its time in the open. It is looking for insects, primarily. It has broad, differentiated teeth, unusual in an animal of this size and age, and it uses these teeth to catch and process the invertebrates that constitute most of its diet. The differentiated teeth are important. Most of the reptiles of the Permian have simple conical teeth, all roughly the same shape, suited for catching and holding prey, but not particularly suited for processing it into small enough pieces to be efficiently digested. The small synapsid's teeth are different. At the front of its jaws there are smaller, sharper teeth for seizing prey. Further back there are larger, more massive teeth that can crush the hard exoskeletons of beetles and the tough bodies of large millipedes. This dental diversity represents a significant investment in processing efficiency, allowing the animal to extract more energy from each prey item than a simpler-toothed predator could. Energy extraction efficiency is not a trivial matter. In an animal this small, with a surface area to volume ratio that means it loses heat to the environment much faster than a large animal does, the ability to extract maximum energy from every prey item is the difference between surviving a cold night and not surviving it. The small synapsid's descendants will eventually develop the ability to generate their own body heat metabolically, keeping their internal temperature stable regardless of external conditions. That ability, which will be the defining characteristic of mammals, is not yet present. But the energetic demand that will eventually drive its evolution is already present, already shaping the diet and behavior of these small, scaly animals. The small synapsid catches an insect. A large beetle, slow-moving on the sun-warmed rock surface, has not moved quickly enough when the synapsid's head lunged toward it. The synapsid retreats slightly with the beetle in its jaws, working it backward with small head movements until it reaches the crushing teeth at the back of its jaw. The crushing is accomplished in a few seconds. The synapsid swallows and moves on, its eyes already scanning the next rock surface for the next prey item. It does this all afternoon. The same quiet, methodical hunting covering the same territory it always covers, finding the same kinds of prey in the same kinds of places. The rhythm of it is hypnotic in its own way, different from the rhythm of the sea, but not unlike it. Life at this scale is always rhythmic. The rhythm of search and find and eat and rest and search again. The rhythm of the thermal cycle, warm and move, cool and shelter, warm and move again. The rhythm of the seasons, though the seasons in this part of the coastal Permian are mild enough that the rhythm is more one of wet and dry than of warm and cold. Other synapsids are visible in the distance, a little further along the rocky coastline. A group of 3 or 4 individuals, all of roughly the same size, moving through the debris at the base of the cliff in the same methodical way. They are not a family unit in the way mammals form family units. The social bonds of small Permian synapsids are not well developed. They tolerate each other's presence in the same territory, and they may have some mutual awareness of danger that causes them to react to each other's alarm responses, but they are not cooperating in any meaningful sense. They are simply individuals occupying overlapping territories because the territory is productive enough to support multiple individuals. Above them, the cliff face rises to a limestone terrace where a different kind of synapsid is moving, much larger. Perhaps 2 meters long, its body thick and muscled, its head broad and equipped with large serrated canine teeth. A gorgonopsid, one of the dominant predators of the late Permian land fauna. It has been resting on the warm limestone through the hottest part of the afternoon, as many of the larger land animals do, and now it is becoming active. Its movement still slow and exploratory, but with a contained energy that suggests it will be hunting soon. The small synapsids below it are aware of it. They cannot see it from where they are, but the chemical signals that drift down from the limestone terrace on the afternoon breeze are legible to their olfactory systems as the chemical signature of a large predator. They move more quickly. They stay closer to the base of the cliff, closer to the crevices that offer retreat if necessary. Their search for insects continues, but the efficiency of their searching is reduced because some fraction of their attention is permanently directed toward the chemical signals in the air around them rather than toward the rock surface for prey. This is the constant condition of being a small animal. The necessity of dividing attention between finding food and avoiding becoming food. The ongoing negotiation between the need to move and search and the need to remain hidden and still. The small synapsids of the Permian have been doing this negotiation for millions of years, and they are good at it. They know when to move and when to stay still. They know which crevices are large enough to retreat into and which are too small. They know the difference between the smell of a predator that is resting and a predator that is hunting. And this knowledge, embedded in their nervous systems through millions of years of selection for exactly this kind of awareness, is part of what will allow some of them to survive what is coming. The gorgonopsid descends from the terrace. Its movement is surprisingly quiet for its size. The soft pads on its feet absorb the sound of its steps on the limestone, and the way it moves, with its body low and its head carried level with its shoulders, suggests an animal that has learned to be less visible than its size would naturally make it. It is following a scent trail across the terrace, the scent of a small herd of dicenodonts that passed this way some hours ago and left the olfactory record of their passage in the molecules clinging to the rock. The small synapsids at the base of the cliff register the change in the gorgonopsid's behavior immediately, the shift from the chemical signature of a resting predator to the chemical signature of a hunting predator. They do not analyze this shift. They respond to it. The nearest crevice in the cliff base is occupied in seconds. The small animals press into the dark of the rock, their hearts beating faster, their olfactory systems still monitoring the air outside the crevice, waiting for the chemical signals to tell them that the danger has passed. The danger does not pass quickly. The gorgonopsid moves through the area for several minutes, following its scent trail with the focused attention of a predator that is seriously hunting. It passes close to the crevice where the small synapsids are hiding, and for a moment the chemical signal is very strong, the signature of a large predator, so close that every cell in the small animal's bodies is oriented toward it. But the gorgonopsid does not investigate the crevice. It has a scent trail to follow, and the trail leads past the crevice and along the base of the cliff toward the area where the dicenodonts were last seen. After it passes, the small synapsids remain in the crevice for a time. They are not calculating when it will be safe. They are monitoring the chemical signals in the air, and they will emerge when those signals tell them the predator is far enough away that the risk of emerging is within the range their nervous systems have defined as acceptable. That range is not a conscious calculation. It is a threshold, encoded in the architecture of their nervous systems by millions of years of selection for animals who emerged at the right time and were not eaten. They emerge. Eventually, the afternoon continues. The Gorgonopsid is far away now, following the Dicynodont trail toward a different part of the coastline. The small synapsids return to their searching, working through the debris at the base of the cliff with the methodical energy of animals that understand, in the only way they understand anything, that the time available for eating is limited and must be used efficiently. Down below them, invisible in the sea, you are still floating. The water is still warm. The reef is still breathing. The evening is still approaching in its slow and amber way. The small synapsid above and the brachiopod below are both alive, both successful, both doing what they are built to do in the world that has built them. Neither of them knows about the other. Neither of them knows about the threshold that is approaching in the deep water below the reef. Neither of them knows that the small synapsid's lineage will go on and the brachiopod's lineage will be nearly ended. They only know the present, and the present for both of them is life. The Permian Ocean is a solution. Not a solution in the sense of an answer, though there is something solution-like about the way it has answered the question of where life should go after billions of years of evolution. A solution in the chemical sense, a mixture of water and dissolved substances, the substances in this case being the minerals leached from the rocks of the continents by billions of years of rain and river, carried to the sea and concentrated there over geological time into a specific mixture that has been slightly different in every era of the Earth's history, and is this specific mixture right now, in the late Permian, in the warm tropical shallows where you are floating. The dissolved substances include sodium and chloride, the components of ordinary salt, which make the seawater taste the way it tastes. They include calcium and magnesium and potassium and sulfate and bicarbonate, each one in a specific concentration that reflects the balance between input from the rivers and removal by the organisms that use these elements in their chemistry. They include dissolved gases, oxygen and carbon dioxide, and nitrogen and small amounts of many other gases, each in a concentration that reflects the balance between what the atmosphere puts into the water and what the water takes out. They include, in very small concentrations, traces of every element in the periodic table. The sea is not selective about what it accepts from the rivers. It takes everything that dissolves, and it accumulates it over geological time, and the result is that the Permian Ocean contains, somewhere in its vast volume, atoms of every naturally occurring element. Some of these elements are present in tiny concentrations, measured in parts per billion or parts per trillion, but they are there, and some of them are essential for life in concentrations so small that the organisms that need them have evolved extraordinarily sensitive systems for finding and concentrating them from the dilute soup of the sea. Iron, for example. Iron is essential for the chemistry of oxygen transport in blood, and it is also essential for the photosynthetic machinery of the algae and the planktonic organisms that form the base of the ocean's food web. But iron is not very soluble in oxygenated seawater. It tends to form insoluble compounds that sink to the seafloor and are removed from the productive surface layers. In certain parts of the Permian Ocean, far from the land and the rivers that bring iron-rich sediment to the sea, the concentration of dissolved iron in the surface water is so low that it limits the growth of phytoplankton even when light and nutrients are otherwise abundant. This iron limitation is not unique to the Permian. It is a feature of the open ocean in every era of the Earth's history, and the organisms of the Permian have developed the same strategies for dealing with it that the organisms of every other era have developed, producing specialized molecules that bind to iron and carry it through the cell membrane, competing intensely for every available atom. The chemistry of the Permian Ocean is also, in certain subtle ways, the chemistry that is already beginning to shift. The carbon dioxide concentration in the seawater is higher than it was 1 million years ago because the atmosphere has been accumulating carbon dioxide from the Siberian eruptions, and the sea has been absorbing some of this excess carbon dioxide, as it always does. Higher carbon dioxide in the water means a lower pH, a slightly more acidic water. The change so far is small. The pH of the Permian surface ocean is still well within the range that most of its organisms can tolerate, but the direction of the change is consistent, and the rate of change is accelerating as the volcanic eruptions add more and more carbon dioxide to the atmosphere. You can feel none of this. The water around you has a pH that is indistinguishable to your skin and your lungs and your senses from the pH that the water had 1 million years ago. The warmth is the same. The clarity is the same. The oxygen content is the same. If you could somehow compare the two waters, the 1 million-year-ago water and the today water, the difference would be chemical in nature, requiring sensitive instruments to detect. The organisms of the reef are somewhat more sensitive than instruments, and some of them are beginning to register the change in their calcium carbonate deposition rates. The shells and skeletons building slightly less quickly, the material slightly less dense. But even this change is subtle enough that it does not, yet, register as a crisis. The chemical history of the Permian Sea is written in the rock. The limestone that underlies the reef contains a record of every chemistry the water has passed through, encoded in the specific ratios of isotopes and elements in the calcium carbonate that was precipitated from the water. Future scientists will read this record and from it reconstruct the temperature of the Permian Sea and the carbon dioxide content of the Permian atmosphere and the timing and magnitude of the changes that led to the extinction. They will do this with instruments of remarkable sensitivity, extracting signals from rock that looks, to the naked eye, like ordinary rock, and they will produce a detailed, high-resolution picture of exactly what happened to this chemistry over the course of the extinction event. That record is already being written, right now, in the shells of the brachiopods and the skeletons of the corals and the tests of the planktonic organisms sinking to the seafloor. Every organism that builds a calcium carbonate structure is contributing to the record, incorporating into its structure the chemical signature of the water it lived in at the moment of its growth. The record is not continuous. There are gaps and ambiguities and signals that are difficult to interpret. But it is there, and it is accumulating, and 250 million years from now, it will tell the story of this sea to the scientists who are patient enough and clever enough to read it. You are floating in a chemistry lesson written in water. The specific composition of the water around you, its temperature and its pH, and its dissolved gas content, and its mineral concentrations, is the specific text of a specific moment in the chemical history of the planet. Every molecule of water that touches you has a history. It has been rain and river and ice and vapor and sea, cycling through the Earth's systems for billions of years, and its current composition reflects all of that cycling. The hydrogen in the water molecules was forged in the Big Bang. The oxygen was forged in the cores of stars that exploded before the sun was born. The calcium dissolved in the water was forged in the same stellar explosions and incorporated into the rocky material of the young Earth and leached from the rock by billions of years of rain. You are in the oldest water you will ever touch, and it is also the newest water you will ever touch, because the water molecules are constantly moving, constantly exchanging atoms with the surrounding chemistry, constantly becoming part of new compounds, and then reverting to water again. The water that is now touching your skin has been part of a coral skeleton and part of a fish's blood and part of the atmosphere above the reef, all within the last few years. The atoms in it have been part of everything. This is what the sea is, at its most fundamental. Not a setting for the lives of its organisms, but a chemical medium in which those lives are embedded, and through which the chemistry of the entire planet moves and exchanges and changes. The sea does not contain the water cycle. The sea is part of the water cycle, continuously exchanging water with the atmosphere above and the rock below, continuously receiving the chemistry of the land through the rivers and continuously returning it through the evaporation and precipitation that takes water from the sea back to the land. The chemistry is moving right now, around you and through you and in the invisible microscopic processes of every organism in the reef and the water column. The coral polyps are taking calcium and bicarbonate from the water and precipitating them into calcium carbonate for their skeletons. The photosynthetic organisms are taking carbon dioxide from the water and converting it into organic carbon for their bodies. The bacteria are taking nitrogen from the water and converting it into forms that other organisms can use. The fish are taking oxygen from the water and converting it into the energy that powers their muscles. All of this chemistry is happening simultaneously, in the same water, in the same moment. Let the chemistry continue without your attention. You do not need to track it. It has been running without observation for 99 million years, and it will run without observation for however much time it has left. You are in it, but you are not required to understand it. You are only required to be in it, and being in it is something that requires nothing but presence. The water is warm, the chemistry is ancient, the reef is breathing. The afternoon light is moving toward evening in the way it always moves, slowly and without drama. And you are here, in the oldest sea, in the warmest water, in the last full afternoon of a world that has no words for its own ending. Let that be enough. It is enough. The water is warm, the sea continues, and you are here in it. In a crevice below you, at a depth of about 6 meters, a trilobite is resting. You saw it earlier, in the afternoon of the first day, and it has not moved far from where you saw it then. Trilobites do not move much when they are resting. Their metabolisms are low and their energy requirements modest, and the crevice is a good one, sheltered from the main currents that carry suspended sediment that would clog their gills, angled so that the light that enters it is indirect and soft. The trilobite has occupied this crevice, or one very near it, for most of its adult life. It is a large trilobite. Its axial lobe, the central raised section of its segmented body, is dark brown and smooth, worn smooth by years of moving through sediment and over rock surfaces. The pleural lobes on either side of the axial lobe are slightly lighter in colour, patterned faintly with a texture that the scientific literature will eventually call granular, a surface of tiny bumps that increases the surface area of the exoskeleton without significantly increasing its weight. The trilobite's head shield, the cephalon, curves forward and outward from the body, its edges gently arced, and at the front of the cephalon 2 large compound eyes project outward and slightly upward, each one composed of hundreds of individual lenses arranged in a grid. Those eyes can see. They see in a way that is different from the way your eyes see, because the individual lenses of the compound eye do not combine to form a single focused image the way the lens of your eye forms a focused image. Instead, each lens registers a slightly different angle of view, and the combined input from all the lenses gives the trilobite a wide-angle, motion-sensitive picture of its world. The trilobite is not good at resolving fine detail, but it is excellent at detecting movement across a wide field, which is exactly what a seafloor animal that needs to notice approaching predators requires. The trilobite has been seeing with these eyes for the length of its adult life, which is somewhere between 2 and 5 years, depending on the species and the individual. Before it had eyes, when it was in its early larval stages, it navigated by chemical signal and by touch, building its first exoskeleton as a tiny, helmet-like structure called a protaspis, and then progressing through a series of growth stages, each one adding more segments to the body, each one requiring the animal to shed its entire exoskeleton, expand rapidly, and harden a new one before it was vulnerable to compression from the water around it. The molting process is one of the most dangerous periods in any arthropod's life. Between the shedding of the old exoskeleton and the hardening of the new one, the animal is soft and vulnerable, its body unprotected by the calcium carbonate that normally armors it. During this period, it is incapable of moving quickly, its muscles not yet fully attached to the new exoskeleton, and it is simultaneously the most vulnerable to predation and the most attractive to predators, because soft-bodied animals are far easier to eat than armored ones. The trilobite dealt with this vulnerability by retreating to the deepest, most protected part of the available crevice during each molt, remaining motionless until its new exoskeleton had hardened enough to function. It has done this many times. The exoskeleton it is wearing now is not the first it has had. It is perhaps the 15th or the 20th, each one slightly larger than the last as the animal grew through its successive stages. The shed exoskeletons did not disappear when the trilobite left them. They settled to the sea floor, where they were incorporated into the sediment, and some of them will be found by paleontologists 250 million years from now, pressed flat between layers of limestone, identifiable by their distinctive shape as belonging to a specific species that lived in the late Permian Reef environment of this particular region of the ancient Tethys Sea. The Tethys. That is the name the future will give to the sea you are floating in, or to this part of it. The larger ocean that surrounds Pangaea on all sides is Panthalassa, but along the eastern margin of Pangaea, in the zone where the continents have not quite closed together, there is a shallower, warmer arm of the ocean that extends westward into the body of the continent, and this arm will be called the Tethys by the scientists who name it. The name comes from a Greek sea goddess, one of the daughters of the primordial earth and sky. The name is given to this body of water in the distant future by people who will study the rocks that were once its floor, and it has a resonance of depth and antiquity that fits the water it names. The trilobite does not know it is in the Tethys Sea. The trilobite does not know it is in any named body of water, because the trilobite does not have names. It has chemistry and pressure and light and the electrical signals of its nervous system, and from these it constructs whatever experience it has of the world, which is not an experience you can easily imagine your way into, because the gap between the nervous system of a Permian trilobite and the nervous system of a modern human is larger than any gap in human experience could bridge. And yet, the trilobite is alive, and you are alive, and you are in the same water, in the same afternoon, witnessing the same light on the same ancient sea. These facts create a connection that does not require shared experience to be real. You and the trilobite are both expressions of the same planetary process of life building itself from the chemistry of the universe. The trilobite is an earlier expression, more ancient, less complex in certain ways, more specialized in others. But it is the same process, the same chemistry, the same drive, if drive is the right word for what is chemical and not intentional, toward complexity and continuation. The trilobite is one of the oldest surviving lineages on Earth in this moment. Its ancestors were in the Cambrian seas, the first seas complex enough to contain predators and prey, the first seas where the invention of eyes and shells and hard parts changed the rules of existence for everything. The trilobites of the Cambrian were among the most successful animals in those seas, and their success was built on the same characteristics that have sustained their lineage through every catastrophe since. The hard exoskeleton, the compound eyes, the ability to roll into a defensive ball when threatened, the tolerance for a wide range of conditions, the capacity to burrow in sediment when the water above becomes hostile. They will not survive this extinction. The trilobites have made it through the Ordovician extinction and the late Devonian extinction and the end Carboniferous cooling, each time reduced but not eliminated, each time recovering some portion of their former diversity. But the Permian extinction will be too much. The combination of ocean warming and acidification and anoxia and hydrogen sulfide poisoning will eliminate every trilobite lineage on Earth. After 270 million years of existence, after surviving every catastrophe the planet had produced up to this point, the trilobites will be gone. The last trilobite will die without knowing it is the last. It will die in whatever conditions are present in its specific location, at its specific moment, and its death will be one death among the billions of deaths occurring across the ocean, and nothing in the ocean will register its significance. The other organisms dying around it will be too concerned with their own dying to register anyone else's. The survivors will not know they have outlasted the trilobites. The gap left by the trilobites in the ecology of the post-extinction ocean will simply be a gap, slowly filled by other organisms that move into the ecological roles. The trilobites vacated. The trilobite in the crevice below you does not know any of this. It rests in its crevice in the late afternoon of the Permian Sea, its compound eyes registering the slow changes in light that tell it the day is aging. Its metabolism is at its resting rate, its gills moving the water through their delicate surfaces in the slow rhythm of an animal at rest. It is comfortable, if comfort is a word that can apply to something with a nervous system this simple. It is as much itself as it has ever been, in this crevice, in this reef, in this sea that has no name. You float above it, and you know what it does not know, and the knowing is a kind of gift to bring to the witnessing. To see a trilobite at the end of trilobite time, and know that it is the end, and to be moved by it, not with grief exactly, because grief requires an attachment that you have not had time to form, but with something quieter and more lasting. Recognition. The recognition of a fellow traveller in the ancient business of being alive on a planet that does not guarantee continued conditions. The recognition of something that was here before you and will not be here after you, and that was fully itself in the time it had. The crevice holds the trilobite, the water holds the crevice, the ancient sea holds all of it, and you are here, witnessing, which is what you came to do. The afternoon continues. The light continues, the trilobite rests, and somewhere above you, in the warm air of the Permian afternoon, the light is going amber on the limestone terraces where the synapsids are hunting, and the Permian world is being exactly itself, right up to the last moment it is permitted to be. Let us speak, for a moment, of the world that will grow from this one, not because the future should diminish what is here now, in the warm Permian water, but because knowing something of what comes after might make the ending feel less final than it is. The Permian Sea will end, the reef will die, the trilobites will be gone, the large synapsid predators of the land will be gone. Vast numbers of fish and invertebrates and planktonic organisms and deep-sea creatures will be gone. The extinction will be real and it will be severe, and no amount of perspective from the distant future should be used to soften that. And yet, in the rock that will be left behind, in the compressed sediment of this sea, in the limestone that was once this reef, there will be an extraordinary record. A record so detailed and so legible that scientists 250 million years from now will be able to reconstruct, from the isotopes in the rock and the trace elements in the fossils and the chemical signals in the sediment, almost exactly what happened here, and when, and in what sequence. The Permian extinction will be one of the most studied events in the history of science, because it raises a question that matters deeply to the people who study it. How much can a planetary system take before it fails, and what happens in the failure? And how does recovery begin? These are not purely academic questions for the people who study them. They are questions with contemporary relevance, because the carbon dioxide concentration in the atmosphere of the world those scientists live in has been rising for the past 250 years of their industrial history, and the rate of increase is faster than any natural increase the planet has produced in the past, with the possible exception of the Siberian Traps eruptions. The scientists studying the Permian extinction are, among other things, trying to understand how much margin exists between the current trajectory and a trajectory that ends in catastrophe, and the Permian record is one of the most informative data points available for that question. The answer the Permian record gives is not a comfortable one. The warming that caused the Permian extinction was approximately 10 degrees Celsius above the pre-extinction baseline, and it was produced by a carbon dioxide concentration perhaps 10 times the pre-industrial levels of the distant future scientists' world. The scientists of the future are starting from a lower baseline, but the rate of change in their era is much faster than the rate of change in the Permian, and the interaction of rapid change with a complex system is not well understood. The Permian took thousands of years to tip from stressed but functional to collapsing. The question of how much time the future world has is one the Permian record does not fully answer. But the future is not your concern right now, in this dark and warm water. The future is something that the future will have to handle with whatever tools it has. Your concern, if you want to call it that, is this moment, this water, this reef, this last evening of the Permian world. And this moment is not the future. This moment is ancient and warm and full of life, and the life in it is extraordinary. Think about the crinoid, the sea lily extended in the evening current, its feathered arms tracing their slow arcs through the water in the perpetual motion of feeding. Think about the brachiopod, its shell open to the last warmth of the day, filtering water with a patience that has no equivalent in human experience. Think about the nautiloid, spiraling through the water column in the gathering dark, its chambered shell carrying it buoyantly through the depths with the grace of an animal that has solved the problem of buoyancy so completely that it has not needed to change its solution in 500 million years. Think about the trilobite in its crevice, the gorgonopsid on the limestone terrace. The small synapsid working the rocky coastline in the amber afternoon light, its differentiated teeth processing the chitin of beetles with an efficiency that carries, encoded in it, the distant possibility of mammal teeth, of the molar that will one day crush grass, and the incisor that will one day bite fruit, and the canine that will one day, eventually, become the tooth of the creature that will name all of this. Think about the sea itself, the warm Tethys water, the specific chemistry of this specific moment in the chemical history of the planet, the dissolved minerals and the dissolved gases, and the dissolved traces of every element in the periodic table. The water that has been rain and river and ice and sea for billions of years, cycling through the Earth's systems in the slow, continuous motion of the planetary water cycle. The water that is now your medium, your environment, your surrounding, your context. All of these things are here. All of them are real. They are 252 million years old, which means they are also as present and immediate as anything can be, because presence does not diminish with age. The trilobite in its crevice is just as present as any creature alive in your own time. The Permian Sea is just as real as any sea that exists now. the age of things does not make them less real or less present. It makes them more remarkable because they have persisted through so much, because they are here at all after everything the Earth has been through. The darkness is complete now. The midnight of the Permian Sea, the absolute dark of 252 million years ago, in a sea that has never had a human look into it. The stars above the surface are the same stars that will be in the sky of the distant future, shifted slightly in their positions by the slow motion of stellar drift, but recognizable in their constellations to any human eye that had the extraordinary privilege of standing on the coast of Pangaea and looking up. The stars do not know about the extinction. The stars do not know about anything that happens on the surface of any planet. They simply burn, as they have always burned, as they will burn until their fuel is exhausted, and they too end. Everything ends. This is not a pessimistic observation. It is the most basic fact of the physical universe, that all specific configurations of matter and energy are temporary, that the second law of thermodynamics permits structure only locally and temporarily, and always at the cost of increasing entropy somewhere else. Stars end. Planets end. Species end. Individual organisms end. And in the ending, always, the constituent parts are released to become something else. The atoms and the molecules and the chemical energy redistributed through the system to build new configurations, new structures, new moments of improbable complexity. The Permian Sea will end, and from the chemistry of the ending, the Triassic Sea will begin, slowly, impoverished, reduced almost to nothing, but beginning. The survivors will diversify, the niches will fill again, the reef will be rebuilt by different builders over millions of years, until it is as complex and as rich as what you are floating in now. And then the Triassic will end, and the Jurassic will begin, and the pattern will continue, change and recovery and change again. Each era building on the wreckage of the last, each extinction clearing space for something new. The sea that exists in the time of the scientists studying the Permian extinction is not the Permian Sea. It is something new, built from the remnants of everything that came before, shaped by 252 million years of change and extinction and recovery and evolution. It contains lineages that were present in the Permian Sea, the sharks and the nautiloids and the brachiopods, persisting in modified form through every change. And it contains lineages that did not exist in the Permian Sea, that evolved from the survivors of the extinction and diversified in the post-extinction world, filling niches that the Permian animals could not have imagined. The bony fish, which were present in the Permian but not dominant, will diversify enormously after the extinction and will come to constitute the vast majority of vertebrate species in the world. The marine reptiles, which will recolonize the sea in the Triassic from the land animals that survived the extinction, will for a time be among the most spectacular animals in the ocean, giant ichthyosaurs and plesiosaurs and mosasaurs ruling the Mesozoic Sea. And eventually in the distant future, the descendants of the small land mammals that survived the Permian extinction will venture back into the sea as dolphins and whales, returning to the ocean that their distant fish ancestors left 300 million years ago, bringing with them the large brains and the warm blood and the complex social structures that millions of years of mammalian evolution has produced. The sea continues. The sea always continues. It is the one thing on this planet that has never been absent, that has existed in some form since the first water condensed from the cooling volcanic atmosphere of the young Earth, that will exist in some form until the sun expands to encompass the inner solar system in 5 billion years. The specific animals that swim in it change with every extinction and every recovery. The chemistry of the water changes with the climate and the geology. But the sea itself is permanent, or as close to permanent as anything in the solar system can be. You are in it now, in one of its oldest and most richly inhabited moments. You are floating in the warm dark water of the Permian midnight, above the reef that has been building for 99 million years, under the stars that no human has ever named. And the sea is around you, complete and warm and ancient, and you are in it, and for now, that is everything. Let yourself be here. Let the water hold you. Let the darkness be comfortable. Let the world continue around you in its midnight way, the crinoids and the trilobites and the brachiopods and the nautiloids and the fish of many species all doing what they do in the dark, and let yourself drift in the current of the ancient sea toward the rest that is waiting for you, at the bottom of all of this warmth and darkness and time. Beyond the reef, in the direction of the open ocean, the water changes its character in ways that are felt before they are seen. The reef behind you provides a kind of shelter, not from any specific threat, but from the sense of unbounded openness that characterizes the open sea. In the reef, there are always surfaces nearby. Surfaces to orient to, surfaces to shelter against, surfaces to hide behind or emerge from. In the open ocean, there are no surfaces. There is only water in all directions, extending to depths that exceed the height of the tallest mountains and to distances that exceed anything your land-accustomed sense of space can easily hold. You drift out toward this openness now, carried by a current that has been running along the outer edge of the reef all day and evening, a current that originates in the deeper water of the Panthalasan Ocean and moves through the reef zone on its way to somewhere else. The current is not fast. It is the kind of current you would not notice if you were not paying attention, a gentle, persistent movement of water that carries you without effort on your part. The reef recedes behind you. The individual coral heads become a general shape, and then the general shape becomes a dark line along the horizon of visibility in the dark water, and then it is gone, and there is only the open ocean in all directions. The open Permian Ocean is a world unto itself, as different from the reef as the reef is different from the land. Here, in the water column of the open sea, there are no fixed points, no permanent structures, no architectural features created by organisms. There is only the water, and the creatures that move through it, and the particles that fall through it, and the chemical gradients that organize it invisibly into layers that might as well be different countries for the purposes of the organisms that live in them. The surface layer of the open ocean, the topmost 100 or so meters, is the productive layer. Here, sunlight penetrates deeply enough to support photosynthesis, and the photosynthetic organisms of the open sea, the phytoplankton, use this light to build organic carbon from the dissolved carbon dioxide in the water. These organisms are extraordinarily small. The most important of them are barely visible under even a strong magnifying glass. They are single cells, each one a complete organism, capable of photosynthesis and reproduction and the basic chemistry of life, and they are present in the surface water of the Permian Ocean in numbers that exceed comprehension. A single litre of Permian surface water might contain 100,000 individual phytoplankton cells, or 1,000,000 or more. These cells are the foundation of everything in the open ocean. Every animal that lives here depends on them, directly or indirectly. The zooplankton that graze on the phytoplankton are slightly larger, mostly still invisible to the naked eye, but present in enormous quantities. The small fish and the filter-feeding invertebrates that eat the zooplankton are the first organisms large enough to see clearly, and they are the food of the larger fish and the marine reptiles, and the large cephalopods that are the apex predators of the open Permian Sea. You cannot see most of this. In the dark water of the Permian midnight, the open ocean is invisible in all the ways that count for human vision, but you can feel it. You can feel the enormous emptiness around you, the three-dimensional space of water extending in all directions with no reference points, no surfaces, no edges. You can feel the slight variations in the temperature of the water as different currents move through it, warm tongues and cold pockets that speak of the complex circulation patterns that have been organizing this ocean for millions of years. You can feel the pressure of the water increasing very slightly as you drift, perhaps a little deeper, the weight of the column above pressing gently on your body with its constant and even force. In the dark water of the open Permian Ocean, there are animals moving that you cannot see. Large ones. The Permian Open Ocean supports a diverse fauna of large predators, animals that have no need of the reef structure because they are fast enough and strong enough to make their living in the open water, pursuing prey that cannot hide because there is nowhere to hide. Shark-like animals, their bodies built for speed and endurance, moving through the water column in the long, efficient glides of animals that cover enormous distances in the course of a single day. Large cephalopods, their arms and tentacles extended in the dark water, waiting for the touch of something edible. One of these large cephalopods is nearby. You cannot see it, but if you had the chemical senses of the trilobite, you would know it was there, its metabolic exhalations leaving a faint signature in the water that speaks of a large, muscular animal at rest. It is a nautiloid of a different species from the ones you saw near the reef. one of the open ocean species that has adapted its buoyancy control to cruise the deeper, colder water of the open sea. Its shell is larger than the reef species, perhaps 45 centimeters across, and it has been traveling since early morning in a direction that only its internal navigation system knows. It paused here, in this specific patch of water, because the chemical signal in the water said that prey had passed this way recently. The nautiloid is waiting. It does not have a concept of waiting, exactly, the way you have a concept of waiting, with its associated feelings of impatience or hope or anxiety. It has a behavioral state that is analogous to waiting, a low-energy posture with heightened chemical sensitivity, directed toward the detection of whatever the chemical signal in the water indicates might be approaching. In this state, it is very still, its buoyancy adjusted so that it hangs in the water column without active propulsion, just the faint, constant adjustment of the gas-liquid ratio in its chambers keeping it at this specific depth. Around it, the open ocean is not silent. There is sound in the open ocean, though it is different from the sound of the reef. The reef sound is high frequency, a collection of clicks and snaps and the faint grinding of organisms eating each other. The open ocean sound is lower in frequency, the sound of large animals moving through the water, of currents running against each other, of the deep rumble that travels enormous distances through the water column from geological activity in the seafloor. Sound travels much faster and much further in water than in air, and the open ocean is filled with a low, continuous sound landscape that carries information across thousands of kilometers. The nautiloid registers this sound landscape with the mechanosensory cells on its tentacles and mantle, cells that detect pressure waves in the water, including sound waves, with a sensitivity that allows it to detect very low-frequency sounds over considerable distances. It is aware, in its chemical and physical way, of a large animal somewhere in the water column above it, a vibration pattern that its nervous system categorizes as prey rather than predator, based on the frequency and the pattern of the sound, rather than on any visual information. It adjusts its depth slightly, rising toward the sound, its jet propulsion operating in the minimum cost mode of an animal that is not in a hurry but is moving with purpose. You drift in the open water and feel the enormity of the Permian Ocean around you. 252 million years of accumulation, of organisms living and dying and sinking to the floor and being compressed into sediment and occasionally disrupted by geological activity and beginning again. The sediment on the floor of the open Panthalasan Ocean is hundreds of meters thick in places, a record so detailed that future scientists will be able to read the history of the ocean's chemistry in it with remarkable precision. The open ocean at midnight is very dark and very still. The sound landscape continues, low and constant, carrying its information across distances you cannot comprehend. The nautiloid continues its purposeful drift toward the sound of prey above. The phytoplankton drifts in the surface water, absorbing the last of the afternoon sunlight in its cellular memory and releasing oxygen as a byproduct of the photosynthetic reactions that will continue in the daylight hours. The zooplankton grazes, the small fish feeds, the large fish hunts, and somewhere, in the deepest trench of the Panthalasan floor, the bacteria continue their ancient chemistry in the cold, dark, patient and ancient, and oblivious to everything above them. You are very small in this ocean, smaller than any animal that currently inhabits it. Smaller than the plankton, in a certain sense, because the plankton is part of the ocean, and you are only a visitor, a presence without volume, a witness without substance. And being this small, in this enormous, ancient midnight sea, is not frightening, but is instead the opposite of frightening. It is the specific relief that comes from being very small in something very large. The ocean does not care about your smallness. The ocean does not care about anything. It simply is, and you are in it. And the ocean's not caring is a form of permission to simply be present without effort or consequence. Let the open ocean have you for a moment. Let the open water be around you in all its enormous, indifferent, ancient depth. You are 252 million years old in this moment, or at least you are in a world that is 252 million years old, which is as close as you will ever come to that age. The water around you has been water for longer than that. The atoms in it have been atoms since the first seconds after the Big Bang. Everything that exists is extraordinarily old, and in the face of that oldness, the present moment, in this dark water, in this midnight Permian Sea, is as present and as immediate as any moment can be. Drift here for a while. The reef is behind you in the darkness, still breathing, still alive in its midnight way. The open ocean is around you, enormous and indifferent and alive with invisible life. The nautiloid is somewhere above you, rising through the water column toward its prey, and you are here, floating in the oldest water, in the dark, in the most ancient midnight the world has ever seen. This is enough. This is more than enough. Let the midnight ocean hold you. The night has fully come now. Not the early dark of sunset and the first hours of nightfall, not the middle dark of midnight, when the reef is at its quietest and the bioluminescent signals pulse through the water in their cold blue language, but the deep dark that comes after midnight has passed, and before the first suggestions of dawn have begun to lighten the surface above you. This is the darkest part of the night, in every ocean, in every era. This is the hour when the body, if it will allow itself, descends most completely into rest. Your body knows this hour. It has been tracking it all night in the rhythms of your temperature and your hormones and the electrical patterns of your brain, counting down to this window of deepest rest that evolution has placed in the architecture of the mammalian sleep cycle. You do not have to do anything to arrive here. You only have to stop doing the things that keep you from arriving. You only have to stop holding yourself up. The reef below you has gone very quiet. The night creatures have mostly settled into their routines, and the reef has reached the equilibrium state that follows the drama of the first few nocturnal hours. There is still movement, still feeding, still the constant slow generation and receipt of chemical signals, but the intensity has diminished. The reef is in its equivalent of sleep, the reduced activity state in which the minimum necessary work is done and everything else is suspended. Even the brachiopods, which do not sleep in any recognizable sense, are doing their filtering at a slower rate, because the amount of particulate food in the water is lower at this hour, and the water current is slightly reduced, and the entire system has entered a lower gear that matches the lower demands of the pre-dawn hours. The sea accommodates the night. The sea knows what to do with darkness. You are becoming part of the reef's quietness. The longer you float here, the more your breathing has come to match the rhythm of the water, slow and even and unhurried. Your heartbeat has slowed, not dangerously, but to the resting rate that the body adopts when it is genuinely at rest, when the muscles have released their daytime tension and the brain has stopped generating the rapid sequences of thought that characterize waking consciousness. The water holds the weight of you. This is not a metaphor. The water's buoyancy precisely counteracts the pull of gravity on your body, so that what you experience is not the absence of weight but the precise cancellation of it, a state in which the body floats in a kind of equilibrium between forces, neither rising nor sinking, but simply suspended at the interface between the warm surface layer and the slightly cooler water below. This is the physical sensation of support. This is what it feels like to be held by something larger than yourself. Let the thoughts that are still moving through your mind move at whatever speed they choose, but let them move without your active participation. You do not need to direct them, to follow them, to evaluate them, or respond to them. They are simply the residual activity of a brain that has been busy all day and is now winding down, the last waves of cognitive activity before the brain shifts into the restorative state of sleep. Acknowledge them if you like, with the same patient attention you have given to the brachiopods and the crinoids and the nautiloids, and then let them go. In the Permian Sea, 252 million years from your time, a small and almost transparent planktonic organism drifts in the water column a few meters above the reef. It has been drifting since it was released from its parent organism 3 days ago, and it will drift for some time more before it settles on the reef surface and begins the process of growing into an adult. It does not know what it will become. It does not know anything, in the sense of having information available to consciousness. It is simply alive, drifting, responding to the gradients of light and temperature and chemistry that tell it. In chemical language it cannot read, but its body understands completely where it is and where it needs to go. The lava drifts. The current takes it slightly to the east, then slightly north, then slightly east again. It passes over the edge of a small coral formation and into a clearing in the reef where the current is slightly stronger and the light in the daytime is brighter. It does not know this. It drifts. Below it, the coral polyps are barely active in the darkness, their tentacles mostly retracted, their metabolisms reduced to maintenance. Above it, The surface of the sea is a ceiling of darkness that extends in every direction. You are like the lava in this moment, drifting, the current of the night carrying you, the darkness above and below softened by the warmth of the water and the slowness of your breathing. There is nowhere you need to go. There is nothing you need to do. The reef will continue whether you watch it or not. The sea will continue whether you are in it or not. The Permian night will move toward its dawn at exactly the pace it has always moved, and you will move with it, or you will let it move past you, into the sleep that waits below the drifting. Your eyelids are heavy now, or the equivalent of heavy, in this space between imagining and sleeping. The light behind your eyes has dimmed to the same quality as the light in the Permian Sea at this hour, a quality of almost nothing, of near total dark, interrupted only by the occasional faint flash of something bioluminescent moving through the water nearby. The sounds around you have reduced to the few sounds that are not stimulating but simply present. The low and distant murmur of the ocean's deep currents, the soft movement of water over coral, the imperceptible sound of breathing. The trilobite in its crevice in the reef is very still. It has been still for hours now, its compound eyes registering nothing in the darkness, its appendages folded against its body, its metabolic rate reduced to the minimum that allows it to maintain the chemical processes of life. The trilobite is not sleeping, but it is doing something that serves the same function, a withdrawal from active engagement with the environment, a period of reduced activity that allows the body to restore itself. You are doing the same. Whatever the specific mechanism, whatever the particular biology of sleep in your species and your time, the function is the same. The body needs a period of reduced demand in order to do its maintenance. The brain needs a period of altered consciousness in order to process the day's experiences and consolidate the things worth keeping. The nervous system needs a period of quiet in order to reset and prepare for the next period of waking. You are giving all of this to yourself, right now, in the warmth and the darkness and the quietness of the Permian Sea. You are giving your body what it needs. You are giving your mind what it needs. You are giving yourself permission to stop and to rest and to descend into the part of existence that is not doing or thinking or managing, but simply being, in the way that the reef is simply being, in the way that the Brachiopod is simply being, in the way that the sea itself, enormous and ancient and completely indifferent to anything you might worry about, is simply being. The descent into sleep is not dramatic. It does not have a moment you can point to and say, "There, that was when it happened." It is a gradual settling, like the settlement of particles from the water column to the seafloor, slow and continuous and natural, each particle finding its way down through the layers of water at its own pace, and eventually, without drama and without resistance, coming to rest. Let yourself come to rest. The Permian Sea is here, the reef is here, the ancient darkness is here, the long night is here, and you are here, floating in the warm water of a world that has been here for 252 million years before you, and will be here, in its endlessly changing forms for billions of years after. In the full span of that time, this moment of rest is very small, and very quiet, and very complete. Breathe in, breathe out. Let the water hold you. Let the darkness hold you. Let the reef continue below you, going about its endless patient business. And let yourself go, down into the deep quiet where the trilobite is resting, and the crinoid arms are folded, and the sea is breathing its long, slow breath. And everything that needs to be done tonight is already being done, without you, perfectly, as it has always been done. The night holds, the sea holds, and sleep, patient as the ocean, as deep as the deep water below the reach of light, gathers you in. Before this sea there were other seas. Before the Permian Ocean, with its 99 million years of history and its extraordinary diversity of reef life and open water predators and deep-sea communities, there was the Carboniferous Sea, and before that the Devonian Sea, and before that the Silurian and the Ordovician and the Cambrian, each one different from the others in specific ways that reflect the specific chemistry and temperature and ecology of their respective moments in the planet's history. But each one recognizably a sea, recognizably the same basic enterprise: salt water, photosynthesis, predation, reproduction, the endless circulation of elements through the bodies of living things. The sea that became the Permian Sea began as something else. Before the Permian, the ocean was different. Before the Carboniferous, it was different again. The water molecules themselves are the same molecules that have been the ocean since the beginning, cycling endlessly through the planetary water cycle, rising from the sea to the atmosphere and falling back as rain and flowing to the sea again through rivers. But the chemistry of the water and the biology of the organisms living in it have changed continuously through every era of the Earth's history. The Cambrian Sea, 540 million years ago, was the sea where complex animal life first truly diversified, where the basic body plans of all the major animal groups were established in a burst of evolutionary innovation that still astonishes the scientists who study it. That sea was warmer than the Permian Sea, and its chemistry was different in specific ways, higher in some elements and lower in others, and the organisms that lived in it were radically different from the organisms you are watching now. There were no corals in the Cambrian Sea. There were no brachiopods with their modern form, though the ancestors of brachiopods were there. There were no fish, though the ancestors of fish were there. What there were, in abundance, were trilobites. The trilobites of the Cambrian were the dominant complex animals of their sea in a way that no single lineage has been dominant since. They occupied almost every ecological role that complex animals can occupy in a marine environment. They were predators and scavengers and filter feeders and grazers. They lived in shallow water and deep water and the open ocean. They ranged in size from 1 millimeter to half a meter. Their compound eyes were some of the most sophisticated visual systems that had yet evolved on Earth. And they were successful in a way that has no equivalent in the subsequent history of animal life. They persisted, as a dominant and diverse group, through more than 200 million years of ocean history before the Devonian extinctions reduced them to a remnant of their former diversity. The trilobite in the crevice below you is a remnant of that former diversity. Its ancestors were the masters of the Cambrian Sea, the most common fossils in the rocks of that age, the animals that defined what the ancient ocean looked like. And now, at the end of the Permian, their lineage is reduced to a few dozen species, specialists and survivors, holding on in the ecological corners that more modern organisms have not yet fully occupied. They are not failures. They have lasted more than 500 million years, which is longer than the entire subsequent history of the Earth will be from the moment of the Permian extinction to the present day of the scientists who study it. They are a success story of extraordinary duration that is only ending because of the most severe extinction event the Earth has produced. Think about 500 million years. Think about what it means for a lineage of organisms to persist in recognizable form for 500 million years. In 500 million years, the continents have rearranged themselves entirely from their positions at the beginning of the trilobite lineage to their positions now. The mountains that were high at the beginning of the trilobite lineage have been worn to plains. New mountains have risen and been worn to plains in turn. The ocean chemistry has changed repeatedly in ways that would make the water of the Cambrian Sea recognizably different in chemistry from the water of the Permian Sea. And through all of this, the trilobites have persisted, adapting to each change, occupying each new configuration of the world with some version of the same basic body plan. What is the secret of that persistence? The question is one that the scientists of the future ask about the trilobites and about all the other long-lived lineages, the sharks and the horseshoe crabs and the nautiloids and the brachiopods, the animals that seem to be resistant to extinction in ways that most lineages are not. The answer is not simple. It is not just that these animals are more tolerant of environmental stress, though some of them are. It is not just that they have broader ecological roles, though some of them do. The persistence of these lineages seems to be the result of a combination of characteristics that is rare but powerful. A body plan that is successful over a wide range of conditions, a tendency to inhabit deep water or burrowing environments that buffer them from surface disruptions, and a reproductive strategy that maintains genetic diversity even in small populations. The Permian extinction will test these characteristics to their absolute limits. Some of the long-lived lineages will survive it, the sharks and the nautiloids and some of the brachiopods, because their characteristics prove sufficient against even this extreme test. The trilobites will not, because their characteristics, however powerful over 500 million years, are not quite sufficient against this particular combination of ocean warming and acidification and anoxia. They will join the list of lineages that made it through everything else, but not through this. There is something in this worth dwelling on, not because it is sad, though it is sad in the way that all endings are sad, but because it speaks to the nature of persistence and extinction in general. No characteristic guarantees survival forever. No lineage is extinction-proof. The conditions that make a body plan successful in one era may or may not be sufficient in the next era, and the gap between sufficient and insufficient is sometimes very small. The trilobites were more than sufficient for 500 million years, and then they were not quite sufficient, and that was that. In the dark Permian Sea, the trilobite in the crevice does not know any of this. It knows only the crevice and the current and the chemical signals in the water and the approach of the part of the night when it sometimes moves out to feed on the organic particles in the sediment. Its nervous system is doing what nervous systems do, monitoring the environment, processing the signals, generating the appropriate behavioral responses. It is as alive in this moment as it has ever been, as fully itself as any organism can be, a representative of one of the most successful lineages in the history of life on Earth, resting in a crevice in a reef in a sea that has 12 hours left of its full vitality. The sea is very old. The creatures in it are very old, in the sense that their lineages are old even if their individual bodies are young. The water they live in is old in a way that makes their lineages seem recent, because the water molecules were water before any life existed to use them. The planet they live on is old in a way that makes the water seem recent, because the planet was a ball of molten rock for hundreds of millions of years before the water condensed on its surface. And the star that warms this water is old in a way that makes the planet seem young, though the star is, in astronomical terms, a relatively young star, only about 4.5 billion years old, in an universe that is nearly 14 billion years old. All of this oldness is present in the water around you. Not in a way that requires thought or acknowledgement, simply present, the way the deep water is present below you, even when you are not thinking about it. The oldness of the universe is the background of everything, the context in which the Permian Sea and the trilobite and the reef and you yourself exist. It does not make the present less immediate. If anything, it makes the present more immediate, because the present is the only place where all of this oldness is actually occurring, the only place where it is actually alive and actual. The water is warm right now. That is the present fact. The reef is breathing. That is the present fact. The trilobite is resting in its crevice. The nautiloid is in the water column. The moray eel is hunting. The brachiopod is filtering. The crinoids are extended into the current. The bacteria are doing their chemistry. The phytoplankton is drifting. All of this is happening right now, in the present, in the warm, dark water of the Permian midnight. And all of it is ancient. And none of the ancientness prevents it from being also immediate and present and real. You are in the present moment of a 252 million year old world, and the present moment is the only moment there is, and in this present moment, the world is fully alive and fully itself and fully here. That is everything. That is more than enough. That is the whole point of being in any present moment, in any world, in any time, to be in it, fully, without reservation, as long as the conditions allow. The conditions of this world are about to change, but they have not changed yet, and the present moment, this present moment, is still warm and dark and ancient and full of life, and you are in it. Let the present moment be everything it is. Let the warmth be the warmth. Let the darkness be the darkness. Let the ancient sea be ancient, and let the living creatures in it be alive, and let yourself be here in it, present, warm, held, drifting, descending very slowly toward the rest that the deep water offers. The rest is very close now. The water is warm. The world is old and alive. The trilobite is in its crevice. The sea is breathing. And you are here. Every shell on the seafloor tonight is a letter written by the organism that made it. Not a letter in any language, not a letter with words, but a record, as precise as any writing, of the conditions that prevailed in the water while the shell was being formed. The temperature of the water at the time of formation is encoded in the ratio of oxygen isotopes incorporated into the calcium carbonate. The salinity is reflected in the magnesium content. The rate of growth is visible in the growth lines, the same way that tree rings are visible in the cross-section of a trunk. The shell is not trying to make a record, but it makes one anyway, because that is what chemistry does. It preserves its own conditions in the products it creates. In 252 million years, a scientist will take a tiny sample from one of these shells, a sample so small it is invisible to the naked eye, and run it through an instrument that will separate its components by mass and count the atoms of each isotope present. From those numbers, the scientist will be able to read the temperature of the sea on the night this shell was deposited. Not approximately, not within a few degrees, but within a fraction of a degree, the actual temperature of the Permian Ocean on this particular night, recorded faithfully in the crystalline structure of the calcium carbonate, waiting there in the geological record for 252 million years to be read. The sea remembers everything, not in any conscious way, not in any active way, but the chemistry of the sea and the organisms that live in it, and the sediment that accumulates on its floor, and the rocks that form from that sediment over millions of years, all of these contain records of the conditions that prevailed when they formed. The history of the ocean is written in the ocean's own body, layer by layer, shell by shell, crystal by crystal, over billions of years. This is one of the extraordinary things about the geological record. It is not a record that was made intentionally, not a record that anyone decided to keep. It is a record that accrued as a byproduct of chemistry and biology, and geology following their ordinary processes. The trilobite was not trying to leave a record when it built its shell. The brachiopod was not trying to document the conditions of the Permian Sea. They were only alive, doing what living things do. But in being alive and doing what living things do, they created a record that is still readable 252 million years later. The corals on the reef below you are doing the same right now. The calcium carbonate they are depositing tonight, this very night, in the Permian Sea, is being incorporated into the reef structure in a way that preserves them temporarily. If the reef were to be buried and preserved and eventually exposed as rock, a scientist in a very distant future could sample that rock and read the conditions of this night. Every night is being recorded. Every degree of temperature, every shift in chemistry, every episode of fast growth or slow growth in the reef structure. What does it mean that the universe keeps such meticulous records? What does it mean that nothing is truly lost, that every event leaves a trace somewhere in the physical structure of the world? The trilobites that will go extinct at the end of the Permian will be gone from the living world, but they will not be gone from the geological record. Their shells will be there in the Permian limestone, exactly where they fell, preserved in the stone, readable by anyone with the right tools and the patience to look. Scientists in your time have read these records with extraordinary care. They have counted the species present in Permian rocks and in the Triassic rocks above them, and they have documented the change. Roughly 96% of all marine species gone at the boundary. They have measured the temperature change recorded in the oxygen isotopes, a rise of several degrees in a geologically short time. They have read the chemistry of the rocks, a spike in the carbon isotopes that marks the sudden injection of large amounts of carbon into the atmosphere. They have found evidence of ocean acidification in the dissolution of shells at the boundary layer. They have found evidence of anoxia in the geochemistry of the dark, organic-rich shales that mark the extinction horizon in some locations. All of this is written in rock. All of it was recorded on nights like this one, in seas like this one, by organisms like the ones below you right now going about their ordinary business. The recording is still happening. Tonight's chemistry is being inscribed in tonight's shells and tonight's sediment, one more layer in the immense archive of the Earth's history. You are not leaving a record in the geological sense. Your body, floating in this imagined sea, leaves no trace in the limestone. But in another sense, you are part of the record too. The fact that a person of your time, of your species, is capable of imagining this ocean and thinking about it, and feeling something in response to it, this is also a product of the history recorded in the rocks. The mammal lineage that survived the Permian extinction, the one that eventually gave rise to you, is documented in the fossil record. The path from the small, nocturnal, insect-eating therapsids of the late Permian to the animal capable of reading about them 252 million years later, this path is partially mapped in the rocks. The sea records what happens here. And what happens here tonight, what is happening right now in the warm water above the reef, is the ordinary business of life on a living planet. The brachiopods filter, the crinoids feed, the trilobites forage, the fish hunt and are hunted, the nautiloid navigates the open water, the ancient shark patrols the reef edge, the moray eel navigates the night channels. All of this is ordinary. All of this is what has been happening here for 99 million years. And all of it is being recorded in the chemical structure of the sea and the sediment and the shells of the organisms doing it. There is a kind of continuity in this that is different from the continuity of living things. Living things die, and their lineages either continue or they do not. But the record they leave continues regardless, preserved in rock, accessible to anyone who knows how to read it. The Permian Sea exists right now, in two senses, in this imagined present of 252 million years ago, and in the actual present of your time, preserved in the limestone of places like the Guadalupe Mountains of Texas and New Mexico, in the Permian reefs of the Alps, in the rocks of China and Greenland and many other places where the Permian seafloor has been uplifted and exposed. When you stand on Permian limestone, you are standing on a sea. Not a metaphor of a sea, not a representation of a sea, but the actual seafloor, compressed and solidified, the actual shells of the actual organisms that built these reefs, the actual sediment that accumulated on the actual floor of the actual Permian Ocean. The sea is there. It is just in a different form. Everything the sea recorded about itself is in the rock, waiting to be read. In the water around you now, the organisms are recording themselves without knowing it. The shell being deposited by the brachiopod to your left is recording the temperature of the water right now. The coral polyp below you is recording the acidity of the sea. The fish bones that will eventually settle to the seafloor will record the composition of the fish fauna of the late Permian. All of this will be there, in the rock, available to anyone who looks closely enough, for as long as the rock remains before the subduction zone eventually takes it down into the mantle and melts it back into undifferentiated mineral material. But that is a very long time away. The subduction that will destroy this particular stretch of seafloor is far in the future, so far that it might as well be forever. For now, the record is being made. Tonight's ocean is being inscribed in tonight's shells, and the shells are accumulating on the seafloor, and the seafloor will become the rock, and the rock will wait in the dark for 252 million years, and then someone will come and read it. What does the sea want you to know? Nothing, of course, because the sea does not have wants. But if you imagine it differently, if you imagine the sea as a place that has been recording itself for billions of years and now, through the improbable chain of events that produced you and your capacity to imagine being here, has an opportunity to communicate something across 252 million years of time, what might it say? Perhaps only this: we were here. The trilobites were here, and the brachiopods were here, and the nautiloids and the crinoids and the ancient sharks and the fish and the reef-building corals. They were all here, in this warm sea, going about their lives with the same completeness and the same presence and the same absolute occupancy of their moment that anything alive has ever shown. They were here, and they were real, and they were, in the way that life is always extraordinary when you look at it closely enough. Extraordinary. And now you are here, floating in their sea, if only in imagination, breathing their air, listening to their ocean. Receiving, across 252 million years, the record they left in the rock. The connection between you and them is real, even if it is only chemical, only atomic, only the fact that the same elements cycle through all forms of life and all eras of Earth's history. You are, in a meaningful sense, made of what they were made of. The calcium in your bones may have been in a Permian brachiopod. The iron in your blood may have been in a Permian fish. The carbon in every organic molecule in your body is part of a cycle that has been running without interruption since life began. The sea knows all of this. The rock knows all of this. The long record of the Earth, inscribed in layer after layer of sediment and shell and crystal, knows all of this. And now, floating in the warm dark of the Permian night, with the reef below you and the ancient stars above the surface of the water, and the deep time around you pressing in from every direction, you know it too. You are part of a very old story. The story is still being told. And tonight, for a little while, you are here to listen to it. Let the water hold you. Let the night hold you. Let the story carry you down into the deep quiet where the oldest things rest, where the trilobites sleep in their crevices, where the brachiopods close their shells against the dark, where the sea turns slowly on its axis, and the chemistry records everything, and the record waits, patient as stone, for whoever will come to read it. Thank you so much for watching. If you'd like to see more videos like this, Please consider leaving a like and subscribing to the channel, as it really helps us continue making more content. Anyways, see you in the next one. The water is warm. The water has always been warm. The water will be warm long after this moment and long before it, and the warm is constant, and the warm is everywhere around you, and the warm is what the water is. The reef is breathing, very slowly. The reef is breathing, and the water is warm, and the dark is complete and comfortable, and there is nothing at all that needs to happen. You are drifting, very slowly, the way the plankton drifts, without effort, without direction that it chooses, carried by the current of a sea that has been carrying things for 99 million years and will carry them for 99 million more. The breath comes. The breath goes. The breath comes again. Each breath is longer and slower than the one before it, and there is nothing required between breaths except the stillness of the deep water. The reef is below you. The warm water is around you. The dark sky, the Permian sky, is somewhere above the surface that you are below, and on that sky there are stars that have never been named and will never be named, and they burn without ceasing in the dark above a sea that is fully itself. You are fully yourself. You are the still centre of the warm, ancient water. You are breathing at the pace of the deep ocean. You are sinking very slowly into the rest that is deeper than sleep, the rest of the ancient water, the rest of the reef at midnight, the rest of things that have been still for a very long time. The Brachiopod has its shell barely open. The trilobite is still in its crevice. The nautiloid is somewhere above, spiralling slowly. The deep water is doing its deep work. And you are here, in the warm dark, in the oldest sea, in the quietest moment of the last full night of the world as these creatures know it. Let yourself go down, into the warmth, into the dark, into the long, slow, patient rest that waits at the bottom of all of this. The Permian Sea holds you, the ancient water holds you, and the sleep is waiting for you there, in the deep water, where everything is very still and very warm and very complete. Drift now. The sea carries everything. The sea has always carried everything. And tonight, it carries you. If you like this story, let me know where in the world you're listening from, and what time it is where you are. I'm always curious about that. And if you have a topic you'd like to drift through next, leave it in the comments below. Sleep well,